data modeling. So what is data modeling? If you want to know what exactly the data modeling is, so then first of all, you need to know answers to 3 questions. The first question is, what is data modeling? What is data modeling? Number 2, why data modeling? Number 2, why data modeling? Number 3, when data modeling? Number 3, when data modeling? So if you want to learn the data modeling, first of all, you need to know answers to these 3 questions. What is data modeling? Why data modeling? And when data modeling? So what is data modeling? Data modeling is all about collecting multiple tables together and adding the relationship between them. Data modeling is all about collecting the multiple tables together and adding the relationship between them. As the data modeling is all about collecting multiple tables together. So usually how we are going to get the data is, we are going to get the data in the form of what? We are going to get the data in the form of the dimension tables and also in the form of the fact tables, right? So I have different tables available like this. Okay, here I'm having different tables. So this is going to be the table 1, table 2, table 3, table 4, table 5, table 6. So these are the different tables we're having. Okay. So as here we're having the different tables. So data modeling is all about collecting these different tables together. Okay, and adding the relationship between them. Is what a table contains. So in Power Query, we are going to do what? In Power Query, we are going to do all the data cleaning, data transformation, and then we are going to load those queries into the Power BI. Right? We'll click on what, close and apply. So those queries are nothing but what? The tables. So we are going to collect multiple tables together and adding the relationship between them is called as the data modeling, right? But you get one question. The next immediate question which will trigger in our mind is, why data modeling? As we got different tables together, why we have to add relationship? Without relationship, can't we do the reporting? Let's understand that. So let's say I'm having 2 tables case. One is the first table is the customer table. So here I have like 2 columns, cust ID and cust name. I'm just saving this. I'm naming this as customers. And also I'm having here, I'm creating one more table, sales. The sales table, the sales we are going to get from the cust ID. Okay, order date and sale amount. Customer ID is 1, order date is, let's say, 20th April 2023, 100. So customer ID is 1 again on 20th April 2023, 120. Second customer ID, 21st April 2023, 150. Second customer, 21st April 2023, 180. So here I'm having the sales table as well. This is the sales. So here I'm having two simple tables, guys. Here I'm having two simple tables. What are the two simple tables I'm having? One is the customer table, other one is a customer sales table. What I need to show is I want to create a report. I would like to show customer name and the total sales. I want to show it a report showing customer name and the sale amount. How to get that? Customer name and the sale amount. So customer name is A. How much sale here A has got? Now the data is not available in one table. Now the data is available in two different tables. What are those two different tables, guys? The first table is the customer table and second table is the customer sales table, right? So here the first customer name is A. The first customer name is A. The customer ID here is 1, right? So here also we got customer ID. We can link up these two tables using customer ID and customer ID. So with one here, one is matching, one equal to 1, the sale amount is 100. Again with the one is matching, the sale amount is 120. So the total sale is how much here? 100 plus 120, 220. For A, we got the total sale as 220. And for B, so the total sale here is the 2 and 2 is matching. Again 2 and 2 is matching. For B, total sale here is 330. And for C, there is no total sale here because the customer ID is not available. There is no sale. For D, customer ID is 444. Customer ID is not available. For C and D, there is no sale. I want to create a report like this. The data is available in now two different tables, right? So now let me open Power BI. Let's connect now to these two tables and let's understand. I'm just connecting now to the customer table. And then I'm taking here cost sales as well. So I'm just loading up these two tables, guys, because the data is looking good. I don't need to transform this data. I'm just loading it. So now one good thing what Power BI would add is it will automatically add the relationship between the tables. So now I'm just deleting this relationship, guys. Now I'm just deleting this relationship. So because first of all, we need to understand why data modeling. Data modeling is all about what collecting multiple tables and adding the relationship between those tables, right? So we need to understand first of all why data modeling. So here I got two tables. These two tables are now independent. There is no relationship or there is no link between these two tables. So now I'm going to the reporting tab, the report tab, and then I'm creating a report. Now in the report, I'm just creating here a report with the cost name and the sale amount. Now of taking here the cost name and the sale amount, you could see here for customer A, the sale is 550, for B 550, C 550, and D 550, right? So here we got the total value for every customers. So are these numbers correct? Is A, is A having the sale of 550? How much sale does A has got here? Does A has got here 550 sales?
220.
So you could see here A has got two transactions, customer ID 1. Customer ID 1 means what? A got two transactions. What is total value? 220. But how much we have got here? 550. If you add all the four sale transactions, what is the total value? 100 plus 120, 220 plus 150, 370 plus 180, 550. So the total value is showing up in every row for every customer, which is wrong. This is wrong, right? The report showing up what the wrong values. So why data modeling? Now you came to know why data modeling. Data modeling is very important to get the correct values in the reports. So why data modeling means in order to get the correct values, in order to get the correct values or proper values, correct or proper values between the tables, we need data modeling. We need the relationship between them. We need the relationship between them. So in order to get the correct or the proper values between the tables we are having, we need to get the relationship between them. Without relationship, what we're getting the wrong numbers. Perfect. Now we come to know the importance of the data modeling. But when data modeling, is data modeling possible every time? No. When this data modeling is possible means when we could add the relationship between the two tables, when we could add the data modeling between the two tables. What is data modeling? Data modeling is all about adding the relationships, right? When we could add that relationship, when we could add that relationship means if both the tables contains a common column. If both the tables contains a common column like customer ID and customer ID, then we could add the relationship. So when the data modeling means if both the tables contains if both the tables contains a common column, then we could add the data modeling or then we could add the relationship. Then we could add the relationship, right? Perfect. So what is data modeling? Let's reiterate again. Data modeling is all about collecting and combining multiple tables together and adding the relationship between them. And why data modeling? Data modeling is very important to get the proper or correct values between the tables. Okay, so we need the data modeling or we need the relationship to get what correct numbers between the tables. But when the data modeling is possible, if both the tables contains a common column, then we could add the data modeling or then we could add the relationship between the tables. Perfect. So again, let's go back to the first question. As data modeling is all about collecting multiple tables together, as data modeling is all about collecting multiple tables together like this. So what type of tables are we going to get? What type of tables are we going to get into Power BI? So I can straight away discuss the data modeling things in the Power BI, but in order to have a good foundation for the data modeling, you need to know some basic concepts, guys. So you need to keep your basics right. So you need to know what type of tables you are going to get in the real time whenever you are doing the data modeling. So I'm going into the much deeper in the data modeling. I'm discussing some data modeling conceptualities, right? If you know the concepts right and if you know the concepts in the better way, then when we go to the practical mode, in the practical mode of the data modeling, you could easily do the data modeling. So first let's talk about the conceptualities. Okay, so as the data modeling is all about collecting multiple tables together, what type of tables are we going to get in real time? Or what type of tables we generally get into the Power BI? What type of tables we do get generally into the Power BI? So what type of tables we generally get into the Power BI means the Power BI is what? Power BI is a BI tool. BI is part of what? BI is part of the data warehouse. So in the data warehouse, we mainly get two types of tables. In the data warehouse, we mainly get two different types of tables. Or in the data warehouse, the information going to get stored in the form of two different types of tables, guys. In the data
Dimension
warehouse,
tables,
hello?
dimension tables and fact tables.
Yeah, let me tell you that. So in the data warehouse, the information would get stored in the form of two types of tables. The two types of tables are number one, master table, and number two, the transaction table. Take any data warehouse. In any data warehouse, information going to get stored in the form of two different types of tables. The two different types of tables are number one, master table, and number two, transaction table. So what is a master table? What is a master table? Any table which contains the information about the business. Any table which contains the information about the business is called as the master table. For example, let's take supermarket. How any supermarket going to run their business, guys? How any supermarket going to run their business? Any supermarket will run their business by offering what different products. Without the products, can they run their business, guys? Without the products, can they run their business? No, right? Without the products, they can't run their business. So let's say I have different products like P1, P2, P3 like that. So these products will act as the master table for the supermarket. Because without the products, they won't get the customers. Without the customers, they won't get the revenue. Without the revenue, they can't sustain in their business. Similarly, if you take, let's say, college, how any college going to run their business is? How any college going to run their business?
Based on courses.
Exactly. So any college will run their business by offering different courses. Without the courses, can a student join in the college? No, right? So courses will act as the master table for the college business. Or let's take any hospital. How the hospital going to run their business? How the hospital
Based on
going to run their
treatment.
business? By offering
Based on
different
treatment.
specialities, right? By offering different specialities. Based on the specialties, the patients will come and they will take the treatment. Without the specialties, the patients won't come. So like that, if we take any business, the business related information going to get stored into the master table. So master table, it contains the information about the business. And what about transaction table? Transaction table, it contains the metrics information. Transaction table, it contains the metrics information. Transaction table, it contains the metrics information. What are metrics? What are metrics? Metrics are the measuring points of the business. Metrics are the measuring points of the business. So metrics are nothing but the numbers which are used to analyze the business. So transaction table, it contains the metrics information. What are metrics? Metrics are the measuring points of the business, guys. Metrics are the measuring points of the business. So for example, let's say the supermarket business is there. How we could measure the supermarket business? So how we, here, how we could know which products are doing well or which products are not doing well? Similarly, we got different courses. How we could come to know which course is doing well or which course is not doing well? Let's take the products. How to know which product is doing well or which product is not doing well based on the sales or based on the profits, right? Or based on the orders. Similarly, course is there. How to know which course is doing well or which course is not doing well? So how to know which course is doing well or which course is not doing well is based on the number of students or based on the number of placements. So again, we're going to use some numbers. So transaction table contains those numbers. So as it contains the metrics, metrics are nothing but the numbers. Metrics are nothing but the numbers. Okay. Metrics are nothing but the numbers which are used to Metrics are nothing but the numbers which are used to analyze the business. Metrics are nothing but the numbers which are used to analyze the business. To analyze any business, we need some numbers. Those numbers are called as the metrics. Okay. So I repeat again, how the information going to get stored at the data warehouse, guys? In any data warehouse, information going to get stored in the form of two tables. Number one, master table, and number two, transaction table. So what is a master table? Master table, it contains the information about the business. And what is a transaction table? Transaction table, it contains the metrics information. What are metrics? Metrics are nothing but the numbers which are used to analyze the business. Then how we can link the master and the transaction? Master always act as the parent, guys. Master always act as the parent and transaction always act as the child. And transaction always act as the child. So how could we define this parent-child relationship? How could we define this parent-child relationship is using primary keys and foreign keys. So in the master table, we are going to use or we are going to take the primary key, and the transaction table contains the foreign keys. Master table contains the primary keys. Transaction table contains the foreign keys. What is a primary key, foreign key? We'll discuss shortly. With the help of the primary keys and foreign keys, we are going to add this parent and child relationship. Because without the master, transaction won't exist, guys. As always, master is acting as a parent. Without the master, transaction won't exist. It means without the products, can sale exist? Can we get the sales without products, guys? Or without the courses, can we get the students? Or without the courses, can we get the revenue? Or without the products, can we get the profits? No, right? So without the master, transaction won't exist. So master always acts as the parent. So master always acts as the parent and transaction always acts as the child. So to define this parent and child relationship, to define this parent and child relationship, we are going to use the primary keys and foreign keys. So what the master table contains is, master table contains primary keys plus primary key plus non-numeric information. Primary key plus non-numeric information. Transaction table contains foreign keys plus numeric information. Transaction table contains foreign keys plus numeric information. So master table contains primary keys plus non-numerical information, guys. So as the transaction table contains numbers, master table mostly contains non-numerics. Non-numerics means what? Non-numeric means it can contain textual information, it can contain the dates, it can contain the logicals. So master table contains all the non-numerical information. Non-numerical means it could be anything. Text, date, logical, it could be anything, right? So then how can we differentiate the master and transaction? So how can we differentiate the master and transaction is based on their behaviors. Based on their behaviors. Master always going to behave in the master always going to behave in the two ways case. It is going to behave in the dimensional way or in the measure way. Master always going to behave in two ways, either in the dimensional way or in the measure way. Again, the transaction also going to behave in the two ways. Again, transaction also going to behave in the two ways, either in the dimensional way or in the measure way. So transaction also going to behave in the two ways, either in the dimensional way or in the measure way. So master table is just going to behave in the dimensional way in 99% cases. Master table is just going to behave in the dimensional way in 99% cases, whereas master table going to behave in the measure way in only 1% cases. In only 1% cases. And transaction table going to behave in the dimensional way in only 1% cases. And transaction table going to behave in the measure way in 99% cases. Okay. So dimension and behaviors are the, dimension and measure are the behaviors at the data warehouse level. Dimensions and measures are the behaviors at the data warehouse level. At the data warehouse level, these dimensions and measures are the behaviors. Okay. So master table most of the times going to behave in the dimensional way, and transaction table most of the times going to behave in the measured way. Transaction table most of the times going to behave in the measured way. Okay. So as transaction table most of the times behave in the measure way, and as master table most of the times behave in the dimensional way, what is a dimension and what is a measure? What is a dimension means dimension, it defines the way we want to see our business, or the dimension, it defines the way we want to analyze our business. The way we want to analyze our business, the way we want to analyze our business will be defined by the dimension guys. So dimension, it defines the way we want to analyze our business. Then how can we define the measure? Measure, it defines the way we want to, based on which numbers we want to analyze will be defined by the measure. So first let's understand the dimension. So what is the dimension? Dimension, it defines the way we want to analyze our business, or the way we want to see our business. The way we want to see our business. So for example, let's take the following information. So I'm having products, I'm having department, I'm having sales, and I'm having profit. So let's say I'm having the products, P1 belongs to department D1. Again, I'm having product P2, it belongs to department D1. Let's say I'm having product P3 and it belongs to department D2. P4 and it belongs to department D2 again. So here I'm having two departments, guys. And I'm having the sales and profit. Let's say for P1 we got sale as 100, profit as 10. So next again for P2 we got the sale as 120, for P3 140, for P4 160. The profit we got is 10, 12, 14 and 16. So these are the numbers we have got here for these products. Now I would like to analyze this. So we could analyze here in the products way. It means we could compare here. Product-wise sales. So we could take here product-wise sales, or we could take here department-wise sales, right? And even we could take here and even we could take here both the dimension-wise sales. So we could analyze in the products way, we could analyze sales in the products way, we could analyze sales in the departmental way, and also we could analyze sales in both the dimension ways, both in the product and department, both in the product and the department way. So we could analyze here department wise, product wise sales. So we could analyze here the information either in one dimensional way or in the multi-dimensional way. So what here these two dimensions are offering here? So here products and departments are what? Here products and departments are masters. Sales and profits are what? Measures. These two are what? Measures, right? Because this two contains what? Numerical information. These two are what? Masters. What are masters? Masters contains information about the business. So let's take, we have a supermarket business. They're offering different products, belongs to different departments. And based on this masters, we got the transactions. Based on the products and departments, we got the sales and we got the profits. So we got up the transactions here. So now, in order to analyze here the sales and profit, how to analyze? We can analyze the sales in this products dimensional way, or in the departmental dimension, or we could analyze sales in both department and product as well. So we could analyze in one dimensional way, or even we could analyze in the multi-dimensional way. So dimension, it defines the way we want to analyze our business. Then what is a measure? Then what is a measure? Measure, it defines which data we want to analyze. So let's say I would like to analyze in the products way. I have four products, P1 to P4. As here we got four products, P1 to P4. Which data we would like to analyze here? Are we going to analyze the sales, or are we going to analyze the profits? So which data we would like to analyze will be defined by the measure. Measure, it defines which data we want to analyze. Either sales data we would like to analyze or profits data we would like to analyze. So which data we would like to analyze will be defined by the measure. Which data we would like to analyze will be defined by the measure. So dimension, it defines the way we want to analyze, and which data we would like to analyze will be defined by the measure. Perfect. So now the most important point is, if you're doing any analysis, every analysis in Power BI, what we are going to do every day? In Power BI, every day we're going to perform reporting and analysis, right? If you're doing any analysis, each and every analysis is the combination of both the dimension and measure keys. Each and every analysis we perform is the combination of both the dimension and the measure. Is the combination of both the dimension and the measure. Okay, with only dimension, with only measure, we can't perform any analysis. With only dimension and with only measure, we cannot perform any analysis. Every analysis is the combination of both the dimension and the measure. Let's take, for example, I'm taking only here dimensions. I'm taking only products. With only taking products, can we tell here which product is doing well or which product is not doing well? No, we cannot tell, right? Similarly, by taking here only the sales, can we tell here which product got more sale, which product got less sale? By taking only products, we can't able to perform any analysis. By taking only sales, we can't able to perform any analysis. By taking only products, we can't able to perform any analysis. By taking only sales, we can't able to perform any analysis. So if you're doing any analysis, means every analysis is the combination of both the dimension and the measure. Every analysis is the combination of both the dimension and the measure. Okay, that is the beauty of the data warehousing is. Not only in the data warehouse, every day, knowingly or unknowingly, every day, knowingly or unknowingly, we are going to perform a lot of analysis. Every analysis we do, is the combination of both the dimension and the measure. For example, let's say you want to compare city-wise temperatures. Now we're in summer. I would like to compare two things, city and the temperature. Let's say Hyderabad, Bangalore, Chennai. I'm just taking different cities. I'm taking the temperature. Let's say Hyderabad, 35 degrees, Bangalore, 30 degrees, like that. I'm comparing here the city and the temperature. So what is city here? City is the dimension, temperature is the measure. Without the city, can the temperature exist? Without the city, can the temperature exist? No, right? So without the master, the transaction won't exist. And by taking only cities, can we tell which city is having more temperature? No. If you want to do that analysis means every analysis is the combination of what? Every analysis is the combination of both the dimension and the measure. With only dimension or with only measure, we can't able to perform any analysis. Okay. So let's recap again what we have discussed till now. So at the data warehouse level, how the information going to get stored? At the data warehouse level, information going to get stored in the form of two tables. What are they? Master table and the transaction table. What is master table? Any table which contains the information about the business is called as a master table. And what is transaction table? Transaction table, it contains the metrics information. What are metrics? Metrics are nothing but the numbers which are used to analyze the business. Metrics are nothing but the numbers which are used to analyze the business. So, as the transaction table contains the metrics, how can we differentiate the master and transaction, or how can we relate the master and transaction? Master always acts as the parent and transaction always acts as child. To define that parent-child relationship, we are going to use the primary keys and foreign keys. Master table contains the primary key and transaction table contains the foreign keys. In order to define that parent-child relationship, we are going to use the primary keys and foreign keys. So what the master table contains? Master table contains primary key plus non-numerical information, and transaction table contains foreign keys plus numerical information. So how can we differentiate the master and transaction is based on their behaviors? Master always going to behave in the dimensional way in 99% cases, and transaction always going to behave in the measure way in 99% cases. So as a result, master table is also called as dimension table, and transaction table is also called as the measure table. So then what is a dimension? Dimension, it defines the way we want to analyze our business or the way we want to see our business. Measure, it defines which data we want to see. Measure, it defines which data we want to see. Okay, and the most important point is if we're doing any analysis, every analysis is the combination of both the dimension and the measure. Every analysis is the combination of both the dimension and the measure. With only dimension and with only measure, we can't able to perform any analysis. Every analysis we do perform, every analysis we do perform is the combination of both the dimension and the measure. So again at the data warehouse level, these dimensions have been classified into different types. At the data warehouse level, these dimensions are divided into different types. The different types of dimensions we are having are, now let's talk about different types of dimensions. This is also one of the important entry question. So at the data warehouse level, dimensions have been classified into different types. The different types of dimensions we're having are, the first type is, the first type of dimension we're having is SCD. SCD. SCD stands for slowly changing dimension. SCD stands for slowly changing dimension. So if the data in the dimension is changing slowly, if the data in the dimension is changing slowly over the period of time, then such a kind of dimension is called as slowly changing dimension. So what is SCD? If the data in the dimension is changing slowly over the period of time, then such a kind of dimension is called as the slowly changing dimension. The best example is employees. If you take employees information will change slowly. It means any employee going to work in one organization for some X number of years, after gaining some significant amount of experience, if you want to change the company, he can move to some other company. So employee information won't transfer from one company to other company every day. Employee information will transfer from one company to another company slowly over the period of time. Even if employee want to change the companies every day, no company going to take them, right? Similarly, we take student. The student going to do their schooling in one school for 10 years, and after that their information will move to some board for 2 years, and again their information will move to some university for 4 years. So the student information will change slowly from one organization to other organizations slowly over the period of time. Right. So what is SCD means? If the data in the dimension is changing slowly over the period of time, then such a kind of dimension is called as the slowly changing dimension. And the second type of dimension is RCD. RCD stands for rapidly changing dimension. RCD stands for rapidly changing dimension. If the data in the dimension is changing rapidly, if the data in the dimension is changing rapidly, let's say each and every minute, then such a kind of dimension is called as the rapidly changing dimension. Then such a kind of dimension is called as the rapidly changing dimension. So the data in that dimension will change frequently every minute. The best example is if we take time, every second, 1 second will add to the time. Every minute, 1 minute will add to the time. Every hour, 1 hour will add to the time. So the data in that dimension will change rapidly. So time is the best example for RCD. And number three, the third type of dimension we are having is UCD. The third type of dimension we are having is UCD. UCD stands for unchanged dimension. UCD stands for unchanged dimension, or it is also called a static dimension. If the data in the dimension is not changing at any point of time, if the data in the dimension is not changing at any point of time, then such a kind of dimension is called as the unchanged dimension. The data in this dimension will remain constant. It is also called as the static dimension. It is also called as the static dimension. The best example for the static dimension is gender. The gender won't change, or your date of birth. Your date of birth won't change, right? So the data in these dimensions will remain same, right? So the fourth type of dimension is we're having is shrunken dimension. Shrunken dimension. What is a shrunken dimension? What is a shrunken dimension? The subset or the subpart of one dimension. The subset or subpart of one dimension is called a shrunken dimension. For example, if we take quarter, quarter is part of what? Year. And if we take state, state is part of what? Country. So quarter is the shrunken dimension of year. Quarter is the shrunken dimension of year, and state is the shrunken dimension of the country. So the subset or the subpart of one dimension, the subset or the subpart of the subset or the subpart of another dimension is called as the shrunken dimension. As quarter is part of the year, Quarter is called as a shrunken dimension of the year. And a state is part of the country. State is called as a shrunken dimension of the country, right? The fifth type of dimension is very important, conformed dimension. Conformed dimension. What is a conformed dimension? Okay, if one dimension is commonly sharing across multiple business areas or multiple business segments, then such a kind of dimension is called as conformed dimension. Can you hear me guys? I'm audible? I lost in between. Can you hear me?
Yes.
Yes.
Okay, sorry. So the fifth type of dimension is conformed dimension. What is a conformed dimension? If a dimension is commonly sharing across multiple business areas, or if a dimension is commonly sharing across multiple business segments, if a dimension is commonly sharing across multiple business areas or multiple business segments, then such a kind of dimension is called as the conformed dimension. So let me explain with an example what exactly the conformed dimension is. For example, let's say I'm having three different business areas. The three different business areas we're having school, we're having college, and also we're having let's say bank. So I'm having three different business areas. The three different business areas we're having school. In school, their business is different, and I'm having some bank. In bank, their nature of business is different, and I'm having some government office. In government office, also their work is different. So the nature of work is different in three different areas. As we got here three different business areas, as we got here three different business areas, so every day in these three different business areas, even though their nature of work is different, but they would commonly share one thing is here. What are they going to commonly share here every day? They'll commonly share one
Time.
thing here. What is that?
Time.
Their working time. So they will start their work at morning 9 a.m. and they will end their work at evening 4 or 5 p.m. Their working time is same, and also their working place, their working city, working country. They're going to work, they might work in the same country, if not same, I mean, in same country, they might work in same city. If not same city, they might work in the same state, right? So here, these are the common things or not. So we got here three different business areas. The three different business areas are school, bank, and government office. As we got here three different business areas, in the three different business areas, even though their nature of work is different, they're commonly sharing their time. They're commonly sharing their city of work. They're commonly sharing their state of work like that. So if a dimension is commonly sharing across multiple business areas or multiple business segments, if one dimension is commonly sharing across, if one dimension is commonly sharing across multiple business areas and multiple business segments, then such a kind of dimension is called as the then such a kind of dimension is called as the conformed dimension. Conformed dimensions. Okay. The sixth type of dimension we are having is role playing dimension. If a dimension is playing multiple roles with our measures or with our dimensions, if a dimension is playing multiple roles with our measures we're having, then such a kind of dimension is called as the role-playing dimension. The sixth type of dimension is role-playing. In the role-playing, a dimension going to play multiple roles with the measure. So again, let me explain with an example. For example, let's say you ordered some product in commerce site, let's say in Amazon or in Flipkart, you ordered some product. Here, I'm having two things. One is the product. For the product, we got the order. So with your order for this product, what your order contains? You ordered some product. So what your order contains? Your order contains date of order, right? Whenever you order a product, they'll use you what date of order. Not only the date of order, whatever product contains. So at the time of ordering, you have to pay the amount. It contains the date of invoice. It contains the date of invoice. So it contains the date of order. It contains the date of invoice. And also it contains, once you pay the bill, they'll give you the estimated date of delivery. They'll provide you the date of delivery. And also they will start shipping to give you the delivery. It contains the date of shipping as well. So here with your order, the date is playing multiple roles, guys. With your order, the date is playing here multiple roles. The multiple roles here, the date is playing here. The date is playing here the date of order, date of invoice, date of delivery, and date of shipment. Here date is a dimension which is playing multiple roles with the measure here order. So if a dimension is playing multiple roles, if a dimension is playing multiple roles with our measure, then such a kind of dimension is called as the role-playing dimension. Then such a kind of dimension is called as the role-playing dimension. Number 7, the seventh type of dimension is the seventh type of dimension we are having is degenerated dimension. A degenerated dimension. What is a degenerated dimension? What is a dimension? Dimensions are nothing but the master table. So dimensions contains what? Primary keys plus non-numeric information, right? Dimensions contains primary key plus non-numerical information. So if your dimension contains only the primary keys without any non-numerical information, if your dimension contains only the primary keys, if your dimension contains only the primary keys without any non-numerical information, then such a kind of dimension is called as the degenerated dimension. So for example, let's take customer. Customer is one dimension. What generally the customer table contains? Customer table generally contains customer ID, customer name, right? Customer date of birth, like that. So let's say I'm having customer ID and I'm having customer name and I'm having customer date of birth. Okay. So customer ID has 1, the name is A, and I'm having the date of birth. So here I'm having only customer IDs available, guys. I don't have any customer names or I don't have any customer date of birth. So here only the primary key information is available. Here only the primary key information is available without any non-numerical information. So if your dimension table contains only the primary keys, without any non-numerical information, then such a kind of dimension is called as the degenerated dimension. The eighth type of dimension we're having is the inferred dimension. The eighth type of dimension we're having is the inferred dimension. Empty dimensions are called as the inferred dimensions. The eighth type of dimension is the inferred dimension. What is an inferred dimension? Empty dimensions are called as the inferred dimensions. For example, I'm having the product. What generally the product dimension contains? Okay, product dimension contains in general the product ID and product name, right? So here the product ID is not there and even the product name is also not available. So here the product ID is not available and product name is also not available. These type of empty dimensions are called as inferred dimensions. These empty dimensions we don't use in BI. We don't use in the Power BI. These empty dimensions we frequently use in the ETL guys. And the last type of dimension is the Zunk dimension. The last type of dimension is the Zunk dimension. Zunk dimension acts as the recycle bin for the data warehouse. Zunk dimension acts as the recycle bin for the data warehouse. What does the recycle bin contains? All the unwanted, unrelated information we are going to keep into the recycle bin, right? So at the data warehouse level also, we're going to get some unwanted content. All the unwanted, unrelated content, we're going to place it into the Zunk dimension. These are the 9 different types of dimensions we're having. I'll repeat again. What are the 9 different types of dimensions we're having is the first type of dimension is SCD. What is SCD? SCD stands for slowly changing dimension. If the data in the dimension is changing slowly over the period of time, then such a kind of dimension is called as the slowly changing dimension. The best example is employee or the student. So employee or the student's information will change slowly. So they are the best example for SCD. And number 2, the second type of dimension is RCD. So RCD stands for rapidly changing dimension. If the data in the dimension is changing rapidly, then such a kind of dimension is called as the rapidly changing dimension. The best example is the time. In time, every second, 1 second will add to the time. Every minute, 1 minute will add to the time. Okay. And also the third type of dimension is UCD or static dimension. UCD stands for unchanged dimension. If the data in the dimension is changing, if the data in the dimension is not changing at any point of time, if the data in the dimension is not changing at any point of time, then such a kind of dimension is called as the unchanged dimension or static dimension. Number 4, shrunken dimension. Shrunken dimension, the subset or the subpart of one dimension is called as the shrunken dimension. For example, quarter is part of the year. Quarter is called as the shrunken dimension of the year. State is part of the country. Okay, so state is called as the shrunken dimension of the country. And number 5, conformed dimension. What is a conformed dimension? If a dimension is commonly sharing across multiple business areas or multiple business segments, then such a kind of dimension is called as the conformed dimension. Number 6, a role-playing dimension. What is a role-playing dimension? The dimension is playing multiple roles with the measure we are having, then such a kind of dimension is called as the role-playing dimension. For example, date, if we take with any order, the date going to play with different roles like the date of order, the date of invoice, or the date of segment. So the date will act as the role-playing dimension. And number 7, degenerated dimension. So what is a degenerated dimension? The dimension contains only the primary keys without any non-numerical information. Then such a kind of dimension is called as the degenerated dimension. Number 8, inferred dimension. Empty dimensions are called as the inferred dimensions. Number 9, Zunk dimension. So Zunk dimension always contains the unwanted and the unrelated information. So these are the 9 different types of dimensions we're having at the data warehouse level, guys. Same like this, we have different types of measures that will continue in the tomorrow's session. So all these are the data warehousing basics, guys. You need to know before going to the practical data modeling. So in the last session, we discussed about how the information is getting stored at the data warehouse level, what are the different types of tables we are having, what is a master table, what is a transaction table, what is a dimension, what is a measure, and also we discussed about the different types of dimensions we are having at the data warehouse level. Same like the types of dimensions, we have types of measures. So what are measures? What are measures? Measures are nothing but what? Numbers. Measures or metrics, they're nothing but what? Numbers which are used to analyze the business. To analyze the business, we need some numbers. Those numbers are called as the metrics. Okay. So now let's talk about the different types of measures we are having at the data warehouse level. At the data warehouse level, measures have been mainly classified into At the data warehouse level, measures have been mainly classified into three types. The three types of measures we're having are we are having additive measure, we are having semi-additive measure, and we are having the non-additive measure. We are having the additive measure, we are having the semi-additive measure, and also we are having the non-additive measure. So measures are mainly classified into three types. The three types of measures we're having are additive measure, semi-additive measure, and the non-additive measure. Okay. As the measures have been classified into three types, additive, semi-additive, and the non-additive measures. First of all, what is a measure? Measures are nothing but what? Numbers. As measures are nothing but the numbers, on these numbers, whenever we are performing any analysis, whenever we are doing any analysis, on those numbers, we are going to add some aggregations. On those numbers, we are going to apply some aggregations like sum, average, min, max, etc. So all these are called as the aggregations. So why we need to apply aggregations on these numbers is in order to get the final result, or in order to get the consolidated result, we need to perform aggregations. Without aggregations, we cannot get the consolidated result. So for example, let's take some sample data. So here I have this data. Here I'm having products, department, and sales. So I would like to compare department-wise sales. So here for each department, we got two sales, right? For D1, we have the first sale. For D1, again, we have the second sale. So for each department here, we're having two sales. And again for the department 2 also, here again we're having 2 sales. So as we got multiple values, how we want to consolidate these multiple values? Either you want to add these values, or you want to take average of this, or you want to take min of this or max of this. So we need to do some basic consolidation by applying here sum or average or min or max, right? So on the measures, whenever we are doing any analysis, we need to perform the aggregations to get the consolidated value. So for example, I'm just taking here the department, I'm taking up the total sales. So taking a total sales, now here we have got department is the D1. So the sale here is 220. Again, department is the D2, the sale here is 300. So here we got a department and their total sales. Here we got the department and their total sales. Okay, right. So now for each department, here we're having the total sales. Now, with the total sales, we could able to compare here like which department got more sales or which department got the less sales. So on these numbers, as we are going to perform the aggregations, depending on the supportivity of the aggregations, measures have been classified into 3 types. Number 1, additive measure. Number 2, semi-additive measure. Number 3, non-additive measure. So what is an additive measure? What is an additive measure? If the measure is giving us the meaningful outputs with all the aggregations we are having, if the measure is giving us the meaningful outputs with all the aggregations we are having, then such a kind of measure is called as an additive measure. If the measure is giving us the meaningful outputs with all the aggregations we are having, then such a kind of measure is called as an additive measure. For example, here again we're having sales. On the sales, if I apply sum means here I have applied sum going to give us what? Total sales. Is total sales is giving us the meaningful numbers or not? Whenever we're comparing with the dimension, we're comparing here department-wise total sales. Yes, department-wise total sales is a meaningful value. For each and every department, we could see the total sales. If we take your average sales, we could able to see here what for each and every department, we could see the average sale. If we take min sale or max sale, what we could see here for each and every department, we could see here the minimum sale value, and also we could able to see here the maximum sale value. So if we apply any aggregation of sales, just going to give us what the meaningful result, right? So what is an additive measure means on that measure field like sales or profit, if you apply any aggregation, after applying the aggregation, is that measure giving us the meaningful results or not? So if the measure is giving us the meaningful outputs with all our aggregations, then such a kind of measure is called as an additive measure. So let's go back to once the Power BI. Let's go back to once the Power BI. In Power BI, just connecting to the global sales. And on the global sales, I'm just connecting to the orders data. I'm just clicking on load. On the orders data we are having here, just taking here market. For market, I'm just taking up this sales. Okay, I'm just taking up this sales. So now for each and every market here, we're seeing the total sales. So is total sales giving us the meaningful numbers or not? I mean, is giving us the meaningful analysis or not? So for each and every market, we're seeing up what the total sales information here. When I change the aggregation to average, then it's just going to give us what? For each and every market, we're seeing up your average sales. Again, it is giving us the meaningful analysis. We can change the aggregation to minimum to get for each and every market wise minimum sales. And also, we can change this to maximum to get here each and every market wise maximum sales, right? If you apply any aggregation, it is giving us what? It is giving us here the meaningful result. So sale is an additive measure. Sale is an additive measure. Not only sale, if we take your profit, for profit, if we take sum, it's just going to give us what? For each and every market, we got total profits. If we take average, just going to give us average profits. If we take max or min, it's just going to give us maximum profits or minimum profits. So the point is, if the measure is giving us the meaningful outputs with all the aggregations we are having, then such a kind of measure is called as an additive measure. What about the examples of the additive measures, sir? To take sales, profits, quantity, all these are the examples for the additive measures. And number two, semi-additive measures. So what is semi-additive measure? If the measure is giving us the meaningful outputs, with only few of the aggregations, but not all, then such a kind of measure is called as a semi-additive measure. So semi-additive measures gives the meaningful outputs with only few of the aggregations, but not all the aggregations. Okay, so it means, for example, now again with the market, I'm taking a discount. I'm taking a sum of discount. Yes, the sum of discount is showing up here. Let me make it as percentage. Sum of discounts is giving here like 1,63%, 71,000%, 98,000%, 1,03,000%, 1,39,000%, 1,56,000%, like that. Is there any chance are we going to get discounts like this, case? Is there any chance to get discounts like this? Are these discounts meaningful? No, right? These discounts are not meaningful. These discounts are meaningless. So these discounts are meaningless. This is a meaningless variety. This is a meaningless variety, right? So sum of the discount is giving us the meaningless. I'm changing your aggregation to average. When I change your aggregation to average, now for every market here we got the average discounts like so in Africa it's showing 15.61. It means the average discount they're offering in Africa is 15%, in APAC 14%, in India 19%, like that. Now these numbers are meaningful. So average is giving us the meaningful output, but sum is not giving us the meaningful result, right? So any percentage numbers, any percentage values, any percentage field like discounts or interest rate percentages, all those fields comes under the semi-additive. For example, if you have any loans, like if you have a house loan or if you have personal loan, every month you'll pay the EMIs, right? Let's say you are paying the loan for the last 10 years. And every month you have what the interest rates. So if you sum up all the interest rates for 10 years, so 10 years means every year 12 months, 10 years means 120 months. For 120 months, if you do summation of all the interest rates means, then you'll get what? Interest rate as 700% or 800%. Usually, what are the interest rates? If it is housing interest means it would be in between 6 to 12%. If it is personal loan means it is in between 12 to 18%, like that. So you do sum means sum going to use like 1,000% like that, which is a meaningless. But if you take average means average going to give you like the average interest you paid for this duration of 10 years. If you take min or max means it's just going to give us what the least interest you paid in the duration of this 10 years and also the highest interest you paid in the duration of the 10 years. So Average, min max gives us the proper result, but some it won't. And number three, non-additive measure. What is a non-additive measure? If the measure is not giving us any meaningful outputs, if the measure is not giving us any meaningful outputs, with the list of aggregations we are having, then such a kind of measure is called as a non-additive measure. So non-additive measure means that measure won't gives us the meaningful results, meaningful values with any of the aggregations, then such a kind of measure is called as an non-additive measure. Okay. So the examples for the non-additive measures are latitudes and the longitudes. The examples for the non-additive measures are latitudes and longitudes. So we have the geo coordinates, because if you want to plot anything on the map means we need to take that latitude and longitude. On those latitudes and longitudes, usually we don't apply any aggregation. If you apply any aggregation also, it won't give us any meaningful result. Okay, it won't give us any meaningful result, right? So as a result, it won't give us any meaningful result. It comes under the non-additive measures. So we got altogether three different types of measures. They are additive, semi-additive, and the non-additive. Again, these measures, we are going to combine them into a measure tables. Again, these measures, we are going to combine into the measure tables. Okay. What is a measure table? Measure table is a collection of multiple measures, guys. Measure table is a collection of multiple measures. So all these measures here we're going to combine them into a measure table, right? So here, as all these measures, we're going to combine them into a measure table. We got altogether three types of measure tables. The three types of measure tables we're having are cumulative measure table, snapshot measure table, and factless fact table. Cumulative measure table, or it is also called as fact table. The other name for the measure is fact case. The other name for the measure is fact. As we are finding the facts of the business, so these measures are also called as the facts. Number one, cumulative fact table. Number two, snapshot fact table. Number two, snapshot fact table. And number three, factless fact table. So the measure tables have been classified into three types. The three types of measure tables we're having are cumulative fact table, number one, number two, snapshot fact table, and number three, factless fact table. Number three, factless fact table. So what is a cumulative fact table? What is a cumulative fact table? If the fact table contains, only the additive measures, then such a kind of fact table is called as the cumulative fact table. Cumulative fact table contains only the additive measures. Number two, snapshot fact table. What is a fact table? In the fact table, if you're storing only the semi-additive and the non-additive measures. In the fact table, if you're storing only the semi-additive and the non-additive measures, then such a kind of fact table is called as the snapshot fact table. So first of all, what is a fact table or what is a measure table? Fact table or measure table is a collection of multiple measures. Fact table or measure table is nothing but the collection of multiple measures. Fact table or the measure table is a collection of multiple measures. So all the measures we are going to combine them into a measure table. All the measures we are going to combine them into a fact table. So this fact table is a combination of foreign keys plus fact table is a combination of foreign keys plus metrics. So as fact table is the combination of foreign keys plus metrics, your fact table contains only the additive measures. If your fact table contains only the additive measures, then such a kind of fact table is called as the cumulative fact table. Then such a kind of fact table is called as the cumulative fact table. If the fact table contains semi-additive and non-additive measures, if the fact table contains semi-additive and the non-additive measures, then such a kind of fact table is called as the snapshot fact table. And what is factless fact table? And what is factless fact table? If the fact table contains, if the fact table contains only the foreign keys, so if your fact table contains only the foreign keys without any metrics, without any metrics, then such a kind of fact table is called as factless. So it is factless. Factless means measureless. It is factless. Factless means measureless. These tables are not having any facts. These tables are not having any measures. This table will just have only foreign keys. If the fact table contains only the foreign keys, then such a kind of fact table is called as the factless fact table. So these are the different types of dimension tables and fact tables we're having at the data warehouse level, guys. So again, let me go back to our first point, what I discussed yesterday. At the data warehouse level, information is getting stored in the form of what? The master table and the transaction table, right? So master table is nothing but what? Dimension table. And transaction table is nothing but what? Measure table. So in the dimension tables, we got 9 different types of dimension tables. We got 9 different types of dimension tables. In the measure tables, we got 3 different types of measure tables, right? So the data going to get stored in any of these types, either 9 different types of dimensions or 3 different types of measures. Finally, whatever the dimension tables and whatever the measure tables we are having, we are going to arrange this dimension tables and measure tables in the form of schemas, guys. Whatever the dimension tables and measure tables we are having, this dimension tables and measure tables, we are going to arrange them in the form of schemas. Now, let's talk about what is a schema and what are the different types of schemas we're having at the data warehouse level. So schema is nothing but a collection of multiple tables. So what is a schema means? Schema is nothing but collection of multiple tables together. Collection of multiple tables together is called as a schema. So we are going to collect multiple tables together. We are going to collect multiple tables together and we are going to arrange them in the form of schemas case. So at the data warehouse level, we are having mainly 3 types of schemas. At the data warehouse level, mainly we are having 3 types of schemas. Number 1, star schema. Number 2, snowflake schema. Number 2, snowflake schema. And number 3, mixed schema. So at the data warehouse level, we are having mainly three types of schemas. The three types of schemas we're having are number one, star schema, number two, snowflake schema, and number three, mixed schema. So what is a star schema? What is a star schema? In star schema, we used to have one centralized fact table. So let's talk about first star schema. What is star schema? In star schema, we used to have one centralized fact table. This will be surrounded by multiple dimension tables. So here in the star schema, we used to have one centralized fact table. This is the fact table. This will be surrounded by different dimension table. This is dimension table 1. This is dimension table 2. This is dimension table 3. And this is dimension table 4. So one centralized fact table which would be surrounded by different dimension tables, and in the star schema there is no direct communication between one dimension and another dimension, guys. The most important point is in star schema there is no direct communication between one dimension table and the other dimension table. In star schema, all the dimension tables are in direct communication with the fact table. So no two dimensions are directly linked to each other. In star schema, no two dimension tables are directly linked to each other. In star schema, all the dimension tables are in direct communication with the fact table. So why it is called as the star schema means in the design it looks like star. As in the design it looks like star, it is called as the star schema. And number two, snowflake schema. So data modeling means data modeling is nothing but arranging our tables. So yesterday we discussed about the data modeling, right? What is data modeling? What is data modeling is? Data modeling is all about what? Collecting and combining multiple tables together, right? So how we are going to collect and combine multiple tables together is we are going to collect and combine multiple tables together by creating schemas. By creating schemas. So in other words, data modeling is nothing but creating star or snowflake schemas in Power BI. And the second type of schema is what? The second type of schema is called as the snowflake schema. What is snowflake schema? In snowflake schema, we used to have one fact table. We used to have one fact table which would be surrounded by different dimension tables. So snowflake is just extension to Stargaze. If you extend the star schema, the resulting schema is called as a snowflake. If you extend the star, the resulting schema is called as the snowflake. So here we have a fact table, and here we got the dimension tables DT1, DT2, DT3, and DT4. And here we got DT5, and DT6, DT7, and DT8. This kind of arrangement is called a snowflake. This kind of arrangement is called a snowflake. So in the snowflake schema, we have a centralized fact table. This fact table is surrounded by different dimension tables like this. So in the snowflake schema, the most important point is there is a direct communication between one dimension table and the other dimension table. In snowflake schema, there is a direct communication between one dimension table and the other dimension table. So this kind of arrangement is called as snowflake. And also in snowflake schema, all the dimension tables are not in direct communication with the fact table case. In snowflake schema, all our dimension tables are not in direct communication with the fact table. As all our dimension tables not in direct communication with the fact table, as all our dimension tables are not in direct communication with the fact table. So again, this is called as the snowflake, right? The third type of schema is called as the mixed schema. What is mixed schema? If we combine both star and snowflake, if we combine both the star and the snowflake, the resulting schema is called as mixed schema. If we combine both the star and the snowflake, the resulting schema is called as the mixed schema. Okay, so this mixed schema generally we don't use in real time. In real time, we are going to use either star schema or the snowflake schema. So here comes some important interview questions, guys. In interviews, they're asked like, which schema are you using in your current project? Which schema are you using in your current project? To test your experience, they'll ask these type of questions. So the better answer would be snowflake. In real time, most of the times we're going to design snowflake schemas, right? If it's a snowflake schema, the next question would be, what schema gives you the good performance? Does star gives you the good performance or snowflake gives you the good performance?
Star.
So always star gives you the good performance case. Why star gives us the good performance? So the reason here, the answer for that is what these tables contain. Dimension tables contains what? Information about the business. Fact table contains what? Metrics information, right? So this tables contains information. So selecting the data from a less number of tables is faster, or selecting the data from more number of tables is faster. Let me simplify this. Let's say I'm having two classes. In one class, I'm having 30 students. In other class, I'm having 100 students. Selecting the data from 30 students is faster, or selecting the data from 100 students is faster. The number of students are less, then we could able to get their data in the quicker way. So as a result, so we could able to select the data from the less number of students in the faster way. In that, in the similar way as here, the star schema contains lesser number of tables. As the star schema contains lesser number of tables, we could able to get the data faster. So star gives us the good performance. So star gives us the good performance when compared with the snowflake. So as star gives you the good performance, when you say that star gives you the good performance and snowflake, And the next question would be, a star is giving you the good performance, then why are you using Snowflake in your current project? Then the next question would be, a star is giving you the good performance, why are you going with Snowflake? So the better answer would be, due to the complexity of my client's business, we are using Snowflake. Due to the complexity of my client's business, we can't arrange their data in the form of star. We can't arrange their data in the form of star, so we are using Snowflake. So because of the complexity of my client's design, we are using the Snowflake. If you answer like that, then the next question would be, which schema is more normalized and which schema is more denormalized? Which schema is more normalized and which schema is more denormalized? First of all, to answer that question, you need to know what is normalization and what is denormalization. Normalization is all about dividing your database into more number of tables. Normalization is all about dividing your database into more number of tables. And denormalization is all about opposite to normalization. So normalization means what? Normalization means decomposing your database into more number of tables like this. This is called as normalization. What about denormalization? Denormalization is opposite to normalization. Denormalization is all about decomposing your database into lesser number of tables. Decomposing means dividing. Dividing your database into lesser number of tables is called as denormalization. And decomposing your database into more number of tables is called as normalization. Okay, so which schema contains more number of tables? The star contains more number of tables or Snowflake contains more number of tables, guys? Snowflake contains more number of tables. So Snowflake is normalized. Snowflake is normalized. A star contains lesser number of tables. Star is denormalized. Star is denormalized. And the next question would be, is it possible to convert Snowflake to star and star to Snowflake or not? Is it possible to convert Snowflake to star and star to Snowflake or not? So what's the answer? Okay. So what is Snowflake? Snowflake is an extension to star, right? So question is it possible to convert Snowflake to star or not? Yes. What we can do is, it is different dimension tables we can merge. We have merged in the Power Query, right? We can merge all these tables into a single table, the merge table one. And again, these two dimensions we can merge into the merge table two. Again, these two dimensions we can merge into merge table three. Again, these two dimensions we can merge into merge table 4. So if we combine the different dimension tables into one single merge table, now if you see the output here, you see the fact table, and if you see here the merge tables here, the different merge tables. Okay, then this design is looking like what? Then this design is looking like a star. Then this design is looking like a star. Okay. So is it possible to convert the snowflake to star? Means yes, we can convert the snowflake to star by combining all the different dimension tables into a single merged table. So even though we can convert the snowflake to star, but this approach is not recommended, guys. Why this approach is not recommended is here just we're combining two dimension tables into one merged table. Let's assume that here you got 10 dimension tables. If we combine the 10 dimension tables into one single merged table means, combine the 10 different dimension tables into one single dimension table means, or one single merged table means, then to merge all those 10 different tables, the query will take a lot of time. So again, here, this approach gives you the worst performance. It's just going to degrade our performance. So the question is it possible to convert snowflake to star or not? Yes, we can convert snowflake to star, but that approach is not recommended because it is going to degrade our performance. Then what about star to snowflake? Yes, star to snowflake is also possible. In star schema, if you link two dimensions directly, in star schema, if you link two dimensions directly, or if you add a new dimension to the existing dimension, and if you link those two dimensions directly, then star has turned automatically to the snowflake. This is how we can convert the star to snowflake as well. Right? These are the different types of schemas we're having at the data warehouse level. Okay, and these are the important interview questions. All these are part of the notes. Yesterday I have shared you the notes to your emails. Just refer to the notes where you have all these points. Now, just to understand here the star and snowflake schemas. So let me ask you a question. The question I would like to ask is, let's say for example, let's take some business. For example, let's say you are designing a data model for the hospital business. Okay. So what type of dimensions we're having for the hospital business is? So we need to have a separate table to store the specialities, right? So specialities is one table. So the specialities, yes. So the patients
Doctors.
is second table. They should store this patient data separately. Patient is other dimension table. Next, what else? So we have the doctors table. But the doctor's information we can include in the specialty as well. So I don't think we need a separate table for that. So yeah, I don't think we need it. We need this table. Okay. So the next thing is the hospital went to different branches, right? And also every day they used to get what the appointments. They need to maintain a calendar as well, the dates. The date, the calendar or the dates. And the patient's going to pay the bills, the billing table. So billing table, or I'm just calling it as a revenue table. So if you talk in general, any hospital business would have these dimensions, right? So the bills they used to get from different specialities, the bills they'll get from the patients, the bills they'll get from different dates, and the bill they used to get from different branches. So this kind of design is called as what? Star or snowflake?
Star.
Star.
This kind of design is called as what? This kind of design is called as the
Stars.
star. Now let's recreate the same thing in Power BI. In Power BI, can we create tables or not?
Yes, sir.
In Power BI, can we create the tables or not? Yes, we can do, right? How to create tables? I'm opening a new Power BI window. I'm just going to File and just clicking on New.
By using enter data.
Using entered data, we can create the new tables. I'm naming this table as specialities. Okay, I'm taking the specialty ID, specialty name, and then the doctor name as well, doc name. So one is a specialty. I'm taking a specialty as Auto, taking a doctor name as Ravi, to neuro. Okay, I'm just taking here no, the doctor name as Rana. Perfect. Just loading it, and then let it load. Usually we don't create the tables telling us we don't have any tables for the schema. I'm just tables. So here we got the table. I'm just going to the Power Query. In the Power Query, it's a bit faster. I'll create directly in the Power Query. So then I'm creating here the next table, patients table, taking a patient ID, patient name, and patient specialty. So the patient ID is 1, the name is A, and the specialty is 1, 2B1, 3C2. Just clicking on OK. And again, I'm creating here the date table. I want to get list of dates, guys. How to get list of dates? So I want the dates here, or just I'll create the dates because the patient's going to take the appointment date, right? So here I'm having the appointment date. Perfect. The appointment date is, let's say, 20th April 2023, 21st April 2023. Like this, here I'm having different appointment dates. So I got the appointment table as well. And also I got the branches information as well. I'm adding here enter data again. Next is the branches. So I'm having the branch ID and the branch name. So branch ID is 1. Let's say the branch location or name. Location, let's say, is Hyderabad. And branch ID is 2. The location is Bangalore. So like that, here I'm having different branches. Now finally, the revenue they'll get from what bills. So I have the bills table as well. So the bills we're going to get from the specialty, the bills we're going to get from the patient, the bill we are going to get from the date, and the bill we are going to get from the branch, and the amount. Let's say the specialty is 1, the patient is 1, the date is 20th April 2023, branch ID is 1, the amount he paid is some, let's say, 10,000. So I'm naming this as bills. So here, just to keep you clear, we don't create these tables in real time. We'll get this table from your databases. Okay, so here, just for understanding purpose, I'm creating these tables, and I'm just clicking on OK. And then I'm just clicking on close and apply. So we'll get all these tables into the main Power BI window. Now, as we got multiple tables, the most important thing here is just adding the relationship between these tables. So to add the relationship between the tables, where we need to add the relationship is in the main Power BI window. We got the bottom tab, the model view tab. We need to go to model view tab. In the model view tab, we need to add the relationship. So you could see here by default, we're getting some relationships. You could see the relationships here. So Power BI will automatically add the relationships. Power BI will automatically add the relationships if both the tables contains common column with the same name. If both the tables contains common column with the same name, Power BI will automatically add the relationship guys. For example, if you see here, so in the specialties, here we got the specialty ID. Here also the specialty ID is there. It is adding this line. This line indicates the relationship line. And in the branches, we got branch ID. Here again, we got the branch ID. It is adding the relationship with the branch ID and the branch ID. Here we got the patient ID. Here again, we got the patient ID. It is adding the relationship between the patient and the bills as well. But it is not adding the relationship between the bills and the dates table because the common column name is different here. Here appointment date is there, here date is there. As a common column name is different, it is not adding the automatic relationship. Okay, that's not a problem. We can add the relationship manually. To add the relationship manually, you need to just drag the column and drop it into that common column in the other table. We need to drag the common column from one table and we have to place it into the common column in the other table. Now again, it will automatically add the relationship. Now here we got the relationship like this. So like this, what we can do is we can design the schemas in the Power BI. So what type of schema it is? This is a star schema. So one assignment for you is just take some retail client, let's say Walmart or DMart. So just understand how the Walmart going to do their business and try to create a schema for Walmart. All right. We have a few more things are there in the data modeling. We'll discuss that in the tomorrow. So one assignment for you is just take some retail client, let's say Walmart or DMart. So just understand how the Walmart going to do their business and try to create a schema for Walmart. Let's say, for example, or Walmart or DMart is there. So what are different dimensions the Walmart or DMart going to have guys in their business? What generally the Walmart or DMart going to sell?
Groceries.
Different products, right? Different products. And again, what Walmart have? So who going to take the products? Customers. Think in general. You need to think much deeper. Just think in general how the Walmart going to run their business. As everyone now going to stores for their groceries for shopping every month. Just think in general. Okay, how the Walmart or DMart going to run their business. So they have customers. And again, so they have branches or locations. Perfect. And every day, the transactions will take place. They have the dates as well. Date is common in every business. So date, transaction dates or dates. And they have the revenue. They have the revenue. And the products we are going to get from, the products, again, they have a lot of products, right? They're going to categorize in different categories, like food items, right? So clothing. Okay, sorry, categories. So this is the structure. So what type of schema it is? Is it a star schema or is it a snowflake schema? This is a
Because
snowflake schema. Why it is called a snowflake schema? Because there is a direct communication, there is a direct relationship between here two dimensions. The two dimensions we're having here are product and categories. So here we got the direct relationship between this product and category. As we got the direct relationship between the product and the category, this is a snowflake schema. This is the snowflake schema. Okay, this is the snowflake schema. Perfect. Now let's recreate the same thing in the Power BI. I'm just opening the Power BI. It's just to understand the schema sketch. But again, I'm telling you, no need to create tables in Power BI in real time. In real time tables, we are going to get from our database teams. So I'm just opening here the Power Query. So in the Power Query, perfect. What is the first table you need to create? The first table is the products. What in general the products table contains, guys? How to create a table using enter data. Name this table as the products. Taking a product ID, product name, and the category ID. So the product ID is P1, the product name is, let's say, some A, category is C1. Product ID is P2. So in the products will act as the primary key because every product will have the unique ID guess. No two products will have the same ID. What the dimension table contains or what the master table contains. If you remember my previous session, I said dimension table or master table contains what? Primary key plus non-numeric information, right? So in the products table, this product ID will act as the primary key. What is a primary key means? Primary key is a column in table which contains the unique information and also it contains the non-numericals information. So that column should not have any, that column should not have any nulls and that column should always contains the unique information, guys. So primary key is a column which maintains the uniqueness of a table. In order to maintain the uniqueness of a table, primary key will always contains the unique values and also primary key will never contains the nulls. Right. So again here, the product ID is P3, the name is C and category is C2. P4, the product name is D and the category is C2. Perfect. I'm just clicking on here. Okay. And what is the next table we need to create? Customers. What in general the customer table contains, guys? Customer ID and customer name, right? So again, no two customers will have the same ID. So in the customers table, customer ID will act as, in customers table, customer ID will act as the primary key because it maintains the uniqueness of the customer's information. So I'm taking cust ID as 1, the name is some AA, cust ID 2, the name is BB, cust ID 3, the name here is CC like this. I'm taking here cust ID and their names. Then again, I'm clicking on OK. So we got here the customers table. Right, and we have got the locations as well. I'm just taking up here the locations table. So I'm just taking here, I'm clicking on enter data. Again, the location is a dimension table. The locations contains what? Some primary key should be there, the location ID. Every location will have what? The unique identifier, the location name. So let's say the location ID is 1, the location name is Hyderabad. The location ID is 2, the location name is Bangalore. So here we got the different locations. And then we got the dates. So I'm just taking up here, I'm using again enter data. I'm taking here the dates. So here I'm adding a date column, taking a list of dates. So 1st April 2023, 2nd April 2023, 3rd April 2023, like this. Here I'm taking different dates. So here we got the dates as well. And then we got the categories. Here I'm using enter data again. Naming this table as categories. So I'm naming this as CID, category ID and category name. So category ID is C1. The name is something like AA, triple A. Again, in the category table, this category ID will be the primary key. So, and finally, we need to here add up the revenue column as well. So the revenue column will be the fact table. This is the fact table and all the remaining are what? This is the fact table and all the remaining are the dimension table. This is the dimension table 1. This is the dimension table 2. This is the dimension table 3. All these are the different dimension tables. Now what the fact table contains? Fact table contains the foreign keys. Foreign key plus numerical information. So what the revenue we're getting from the customer, the revenue we're getting from the product, the revenue we're getting from different locations, the revenue we're getting from the dates. Okay. So in order to link this dimension tables and the fact tables, we are going to use this primary keys and foreign keys case. So what is a foreign key means? Foreign key is nothing but the primary key in the other table. Primary key in the dimension table will act as the foreign key in the fact table. So first let's understand what is a primary key and what is a foreign key. And then again, I'll come back to this design. So for example, here I'm having two tables case. The two tables I'm having are one is the customer table. In the customer table, I'm having customer first name, last name, and customer ID. So in customer table, every customer will have a unique ID. So this customer ID will act as the primary key. And I'm having the contact table. So in the contact table, I'm having customer ID, I'm having contact information, and I'm having contact type. So in the contact table, I'm having here different contact types for the same customer. You see, for example, customer 101, the customer name is Stevens. For Stevens, we got here the work number. For Stevens, we got the cell number. For Stevens, we got here the home number. And for Stevens, we got the email ID. And also for Stevens, we got here the fax. For Stevens, even we got here the fax as well. So in the contact table, this customer ID is acting as a foreign key. So what is a foreign key means? Foreign key is nothing but it is a column acting as the primary key in the dimension table or primary key in the other table. So now in the customer table, customer ID is acting as a primary key and the same column is acting as a foreign key in the contact table. Perfect. So now what is the difference between this primary key and the foreign key? What is the difference between the primary key and the foreign key? Now let's talk about the differences. Now let's talk about the differences between the primary key and the foreign key. Let's talk about the difference between the primary key and the foreign key. So primary key is a key column in the dimension table, whereas foreign key is a column in the fact table. It's a column in the fact table. Primary key, it always contains the unique information. Is primary key always contains the unique information, but foreign key contains duplicates, or foreign key allows duplicates, whereas the primary key won't allow duplicates. As you could see here, in the customer table, every customer ID is unique. It's not repeating. But in the contact table, the cust ID is repeating in few rows. Here. Cust ID is repeating in few rows. As cust ID is repeating in few rows, so the data is having duplicates. So foreign key allows duplicates. Okay, contains the duplicates. Now the primary key it won't allow nulls. Primary key, it won't allow nulls. Whereas foreign key, it allows nulls. So primary key, it won't allow nulls, whereas foreign key, it allows the nulls. All right, next. Primary key, a table will have only single column primary key is. A table contains only one column as primary key. So one common question for everyone is, can a table contains multiple columns as the primary key or not? No. Table cannot contains multiple columns as a primary key. Any table contains only one column as a primary key. Whereas a table can have multiple columns as the foreign key. A table can have multiple columns as the foreign key. So a table can contain multiple columns as the foreign key, but a table can contain only single column as the primary key. Okay, single column as the primary key. Okay, and also one more important information is a primary key can exist. A primary key can exist without a foreign key. Whereas a foreign key can't exist. A foreign key cannot exist without a primary key. A foreign key cannot exist without a primary key, right? Because the primary key is nothing but what? Sorry, if a foreign key is nothing but what? Primary key acting in the other table, right? If we don't have the primary key, means the foreign key cannot exist, right? So these are the differences. So now, as we got the foreign keys in the fact table, now we need to design this fact table revenue. So in the revenue, we need to take, so in the products table, what is the primary key column? In the products table, what is the primary key column? PID. So the same PID should be part of the revenue as well. In the products, we got PID. In the customers, what is the column we are having? In the customers, the column here is cust ID. And in the location, what is the column? In the location, the column is LOC ID. In the dates, the column is the date. In the revenue table also, so we need to have the product ID, which is, so this product ID will act as a foreign key. So the product ID is acting as a primary key in the products table. The same product ID will act as a foreign key in the revenue table. And then it should contain the cust ID, should contain the location ID, should contain the date. Now this revenue column is having 4 foreign keys. A table can have multiple foreign keys, but a table can have only single primary key column. Now again, let's go back here to the Power Query and then here add a new table. I'm naming this table as the revenue. In the revenue table, let's take here the product ID, cust ID, location ID, and the transaction date, and then the sale amount. So the product ID is 1, customer ID is 1. So customer, okay, I need to take values. I think I have taken P1. The product ID is P1, the customer ID is 1. I think the location ID is 1 again. The transaction date is 25th April 2023. Sale amount is 1000. Again, a customer can take what? Multiple products, right? He has taken the product P2 as well, the one on the same location on 25th April. If you go to any store, in the store, you can take what? Multiple products. Similarly, I got other customer. So P2, he has taken product P2 customer, second customer, in a different location on 26th April. Sale amount is 1100. P3, cust ID is 2 again, location ID is 2 on 26th April 2023. Sale is 1400. So like this here, I'm having different products, different customers, different locations, and we got the transaction date and the sale amount as well. Let me click on OK. So now this is the fact table. In the fact table, these are the foreign keys. Now we need to add the relationship. So data modeling is all about what? Collecting multiple tables and adding the relationship between the tables or not. As data modeling is all about collecting multiple tables and adding the relationship between those tables. Now we got multiple tables and how we can add the relationship. In Power BI, we can add the relationship based on the common column, right? In order to add the relationship between the tables, we need to have a common column. That common column is nothing but the primary key and the foreign key. So how to add the relationship? In Power BI, we can add the relationship in two ways, guys. In Power BI, we can add a relationship in two ways. So the two ways of adding the relationship are, number one, automatic way, and number two, manual way. In Power BI, we can add the relationship in two ways. Number one, automatic way, and number two, manual way. So when automatic way means what? Automatic way means Power BI will automatically add the relationship. Yes. Automatic way means Power BI would automatically add the relationship. And manual way means we need to add the relationship manually. Manual way means we need to add the relationship manually. Okay. So when Power BI would do the automatic relationship, if both the tables contains primary key, PK means primary key and foreign key with the same name, if both the tables contains primary key and foreign key with the same name, and in the same case, then Power BI would automatically add the relationship. Okay, when we need to add the relationship in the manual way. So in the manual way, we need to define the relationship manually. When we need to do that is if primary key and foreign key are with the different names. If primary key and foreign key are with the different names, if primary key and foreign key are with the different names, then we need to add the relationship in the manual way. Okay, so now let's go back here to again Power BI. I loaded here all the tables. Once go to the model tab. In the model tab, you could see here. So in between the tables, it's automatically added the relationship. In between the categories and products, there is a relationship, automatic relationship using category ID and category ID. And again, in between here, the products and the revenue, see here, there is a relationship automatically added. So now you could see here the data model here, the category got added to the product using here category ID and category ID. Because both the tables contains the common column with the same name. Both the tables contains primary key and foreign with the same name. And to the products and revenue, the relationship has added. You could see here because the common column is same. And in between the location and the products, the relationship has added. Okay, So here, in between the products and the revenue, the common column is location ID. And in between the customers and the revenue also, the relationship has added because the common column is the customer ID. It's not adding a relationship between the date and the revenue. The reason why it is not adding the relationship between the date and the revenue is in the dates, the common column here is date and here transaction date. Common column name is not same. So in that case, we need to add the relationship manually. How to add the relationship manually is we need to drag the date and we need to drop it into the transaction date. So we need to drag and drop the common column and we have to drop into the other table like this. Now here we got the relationship. This is how we are going to add the relationship manually between the two tables. Manually between the two tables. Okay. So now here we got the relationship, guys. This is just to understand the relationship, right? Perfect. So now we discussed now we have discussed here what is a primary key, what is a foreign key, and what is the difference between the primary key and the foreign key. And the next important thing is you need to know about the normalization. What is normalization? Normalization is the process of organizing your database in such a way that to eliminate the data redundancy. The main purpose of the normalization is to maintain the, to reduce the data redundancy, means the data duplicacy, and also maintains the data integrity or preserves the data integrity. Normalization should preserve the data integrity and it should reduce the data redundancy. This is the main purpose of the normalization. This is the main purpose of the normalization. In the normalization, we have got different normalization forms. The different normalization forms we're having first normalization form, we're having second normalization form, we're having third normalization form. Okay, we're having 3.5 or the BCNF normalization form. And also we got the fourth normalization form. And we got the fifth normalization form and also sixth normalization form. These are the different normalization forms we are having. So what are these normalization forms? What is normalization? Let's talk all those in detail. Don't worry about these normalization forms. I'll discuss them in detail. So what is normalization? Normalization, it will reduce the data redundancy. The main purpose of the normalization is to maintain our database in the proper way. In order to maintain our database in the proper way, in normalization, what we will do is we'll divide the database into more number of tables. So normalization is all about decomposing. Normalization is all about decomposing the database into more number of tables. Decomposing the database into more number of tables, decomposing or dividing. In order to reduce the data redundancy and to preserve the data integrity, we are going to divide our database into more number of tables. So what is the standard procedure are we going to follow to decompose the database into more number of tables? So in order to decompose the database into more number of tables, we need to follow the normalization rules. Those normalization rules are called as the normalization forms. Those normalization rules are also called as the normalization forms. Okay, so we have got something called as the denormalization as well. So normalization is all about dividing your database into more number of tables, right? Then what about denormalization? Denormalization is all about dividing your database into less number of tables, guys. Denormalization is all about dividing your database into less number of tables. It is just opposite to the normalization. Okay. So the denormalization is very easy, pretty straightforward. Denormalization is pretty straightforward, but normalization is not like that. So in the normalization, the most important factor what we would consider is maintaining the data integrity. Data integrity means having the data without any duplicates. Having the data without any duplicate. So it reduces the data duplicates, or it reduces the data redundancy. So how we are going to do that? We are going to do that by incorporating the first normalization form or second normalization form or third normalization form like that. So we are going to apply this normalization forms. So on any table, we'll first start with the first normalization form. If we achieve the data redundancy, then we'll stop there. After applying the first normalization form also, if you're unable to achieve the data integrity means, then we'll apply the normalization form 2. Then we'll apply the third normalization form. Like that, we will keep on applying the normalization forms until we achieve the data redundancy, until we achieve the data integrity. Okay, so here as we got the normalization forms up to 6 levels, but in real time we don't use up to 6 levels, guys. Usually we'll do up to third level or at max 3.5 level or BCNF. So let's understand these normalization forms. Let's understand these normalization forms or the different normalizations we are having with some examples. So what the first normalization form says. What the first normalization form says is, in the first normalization form, or the rule of the first normalization form says that every column of a table can't contain multiple values or cannot hold multiple values. So a table is said to be in the first normalization form. A table is said to be in the first normalization form if no column of a table, if no column of a table holding, no column of a table holding multiple values. So it should contain only atomic values. It should contains only atomic values. Atomic values means one single value. It means, for example, I have the following table. For example, I'm having the student table. In the student table, I'm having student ID. I'm having the student ID, student name, and the contact number. Let's say student ID is 1. The name is A. His contact number is something like this. Student ID 2, the name is B. He's having 2 contact numbers. And again, here I'm having the second number as well, like this. Again, 3, the student name is C. He's having the following number. Now you could see here, this table is not in the first normalization form, guys. This table is not in the first normalization form. Why this table is not in the first normalization form? What the first normalization form says? What the first normalization form says is, every column of a table, this table is having 3 columns. The 3 columns are student ID, student name, and the contact number. Every column should not contain multiple values. If you see here, In the student table, the second student is having two contact numbers. The two values. So every column should contain an atomic value like this, guys. Means single value. But here we got two values. Here we got two values. Right. As here we got two values. As here we got two values. This is wrong. This is not in the first normalization form. So we need to convert this to the first normalization form. So how to turn this to the first normalization form? So we need to convert this to the first normalization form. Okay, so we need to convert this to the first normalization form. So how to convert this to the first normalization form is, we need to take here the student ID, student name, contact number. This is not in, all these are for your knowledge sake, is for the data modeling knowledge. Okay. Now 1A, so I'm taking the contact number again, 2B, I'm taking the number again. Again 2B, taking the number again. Again 3C, I'm taking the number again like this. So now this is set to be in the first normalization form because no value of a column is having multiple values. Now it's holding atomic values, but there is no primary key here. This table is not having any primary key. You see here, the student ID is repeating. You see here, the student ID is repeating in two rows. So this is not in the first. Now this is in the first normalization form, but this table is not having a unique column. This table is not having a unique column. So now here this table is in the first normalization form, right? Perfect, but this is not having the proper data integrity. So then we need to apply second normalization form. So what the second normalization form says? What the second normalization form says is, what the second normalization form says is, a table is said to be in the second normalization form. A table is said to be in the second normalization form if it is already in the first normalization form. A table is said to be in the second normalization form if it is already in first normalization form. It should be in the first normalization form, and we have one more rule. The second rule is a table should contain a single column primary key. What the second rule says is a table should contain, say, single column primary key. So every time single column primary key is not possible, guys. Sometimes we are going to define primary key on multiple columns. If we define primary key on multiple columns, then it is called as the candidate key. So first, you need to understand two things. What is a key column and what is a non-key column? What is a key column and what is a non-key column? So the important note point is a key column is used to identify A key column is used to identify the values. A key column is used to identify the values in a table in the unique way. Okay. A key column in a table is used to identify the values uniquely. So key column can be based on single column or multiple columns as well, guys. Key column can be based on single column or multiple columns. If the key column is based on single column, then it is called as primary key. If the key column is based on single column, then it is called as primary key. Whereas if the key column is based on multiple columns, then it is called as the candidate key. Or composite key. So a table contains two types of columns, guys. First, let me add that point. A table, if you take any table contains what data? The table can be the dimension table or master table, transaction table or fact table. Table contains key as well as the non-key columns. Table contains key as well as the non-key columns. So what is a key column? Key column is used to identify the values uniquely. For example, in the customer table, customer ID is a key column. In product table, product ID is a key column. Okay. In locations table, location ID is a key column. So that is called as key column. So key column is used to identify the values in a table uniquely. So this key column sometimes based on single column or sometimes based on multiple columns. If the key column is based on single column, then it is called as primary key. If the key column is based on multiple columns, then it is called as the candidate key or composite key. If the key column is based on the multiple columns, then it is called as the candidate key or composite key. Okay. So then we discussed about key column. What about non-key column? So non-key columns contains duplicates. So non-key columns we don't use to identify the values uniquely. Non-key columns we don't use to identify the data uniquely. So now once we go back to this table, in this table, is table in the first normalization form or not? Yes, this is in the first normalization form because every row contains what atomic value and every column contains atomic value. But is it in the second normalization form? What second normalization form says? Second normalization form says that table should contain a single column primary key. Is there any primary key column here? Student ID cannot act as primary key. Student name cannot act as primary key because two and two are repeating. Student name also cannot act as primary key, right? Even contact number also cannot act as primary key because there is a chance that one student might not have a contact number. So what is the primary key definition? Primary key means it should be unique and it should not contain nulls. But contact number, there is chance of getting the nulls. So it's not in second normalization form. So how to get this into second normalization form? This is not the second normalization form. So how to get this into the second normalization form? To get this into the second normalization form, we need to divide this table into two parts. We need to divide this table into two parts. The first part is the student. So we need to divide this table into two parts, guys. Two tables. We need to decompose. Normalization is all about decomposing, right? So first is student table. The student table, I'm taking his student ID and student name. So 1A, 2B, and 3C. And also we need to create one more table here, contact table. The contact table where student ID and the contact number. Student ID is 1 and here we got the contact number. Student ID is 2, we have the contact number. Student ID 2 again and we have the contact number. Student ID 3 and here we got the contact number. Right. So now like this, if I break down this table, now the student is the now the student table is acting as the dimension table and contact table is acting as a kind of fact table. So it's having the primary key. Every student ID here is unique. But in the contact table, as you could see here, so this student ID is acting as a foreign key. This is a foreign key. And this student ID is the primary key. This student ID is the primary key. So now this is in the second normalization form. Now this is in the second normalization form. Right. And then what about the third normalization form? What about the third normalization form? So what about the third normalization form is what the third normalization form says. A table is said to be in the third normalization form. A table is said to be in the third normalization form if it is already in second normalization form, if it is already in second normalization form and no transitive functional dependencies. No transitive functional dependencies. So what are transitive functional dependencies? So transitive functional dependencies means if we change any non-key column, if we change a value in the non-key column, okay, it should not change the other non-key column. Whenever you are changing a non-key column, it should not change the other non-key column. If it is changing the other non-key column means, okay, then it indicates that there is a kind of transitive functional dependencies. For example, if you see here, this table is in the second normalization form, right? This table is in the second normalization form. So as this table is in the second normalization form, there is a chance that the contact numbers might change. So let's say the contact number got updated. If I update the contact number, would it change the student ID? A change in the non-key column. If I change this is non-key column. This is also non-key column because we can't maintain the uniqueness of a table based on these two columns. If I change the contact number, there is a possibility the contact number might change. For example, I'm updating this contact number. If I update this contact number means, would it change the ID? A change in the non-key column going to change the other non-key column? In this, no, right? So this table is again in the third normalization form because there is no transitive functional dependency. As there is no transitive functional dependency, this is said to be in the second normalization. So this is said to be in the third normalization form as well. This is said to be in the third normalization form as well. So I'm updating this contact number. I'm updating this contact number to, let's say, some different number like this. Now, even if I update the contact number, the student ID remains same. So this is said to be in the third normalization form as well. Let's say, for example, it is changing the other non-key column. It is changing the other non-key column. If it is changing the other non-key column means then what we have to do? Then again, we need to decompose that table into two different tables. Then again, we need to decompose that table into two different tables. Like this in normalization, by applying this normalization rules, what we could maintain is we could maintain the data integrity and we could avoid the data duplicates. So for those purpose only we are going to apply this normalization rules. Up to third normalization form, it's fine, guys. I'll repeat again what the first normalization form says. What the first normalization form says is column should not contain multiple values. Should always contain only atomic values. And what the second normalization form says? Second normalization form says that the column or the table should already be in the first normalization form and table should contain a single column primary key. And what the third normalization form says? The third normalization form says that it is already in the second normalization form and no transitive functional dependencies. Finally, what are the advantages? Finally, what are the advantages of this normalization? No data duplicates. The biggest benefit is no data duplicates. Okay, this is the biggest benefit of the normalization. Okay, and also as there is no data duplicate, the database size won't grow rapidly, guys. Database size won't grow rapidly. Okay, so and also here the data manipulations will happen in the faster way. Data manipulations will happen in the faster way. Data manipulations means inserts, updates, all those things will happen in the faster way. Okay, and here we got some drawbacks as well for the normalization. The drawbacks are as a normalization, we're taking as we're dividing the database into more number of tables, so it needs more number of relationships or more number of joins. Needs more joins due to more tables. Due to more number of tables. Okay, and it gives less performance. So as if you have more number of tables, it gives the less performance because it needs to get the data from more number of tables, right? So these are the advantages and the drawbacks of the normalization. Then what about denormalization? In the denormalization, what is denormalization? Denormalization is just opposite to normalization, right? In denormalization, we're dividing the database into lesser number of tables. So decomposing or dividing the database into lesser number of tables. Into lesser number of tables is called as what? Is called as the denormalization. In denormalization, what are the advantages? The advantages are the advantages of the denormalization are in the denormalization queries will run faster. Queries will run faster. Okay. Okay, and less number of tables. We have some drawbacks as well. The drawbacks are In denormalization, the database size will grow rapidly. What data duplicates? Let's keep it this in this way. Let's keep it in this way. Data duplicates. As a result, database size will grow rapidly. Will grow rapidly. Okay, and now the most important point of the day. In normalization, every table contains every table contains distinct and specific purpose information. Guys, each table contains distinct and specific purpose information. Each table contains distinct and specific purpose information. For example, if you take customer, so customer table contains customer data. Let's say product table contains product data. Let's say date table contains date data. Let's say locations table contains only locations data. And every location is unique, or every date is unique, or every product is unique because it contains the primary key as well. So in normalization, each table contains distinct and specific purpose information. Whereas in denormalization, every table contains multi-purpose information. Guys. Every table contains multi-purpose information. This is the most important point. So which tables contains the multi-purpose information is any fact table. If you take any fact tables, any fact table contains multi-purpose information. For example, just now we have added the revenue table. In the revenue table, here we got the products information, we got the customers information, we got the location information, we got the date information. Whereas if we go to the customers table, we got only customers data. We go to the products table, we got only products data. We got the categories table, we got only categories data. So the point is, or in fact, the point of the day is always dimension tables will be in the normalized form. This point you have to remember. Always dimension tables or master tables will be in the normalized form. Whereas always fact tables will be in the denormalized form. So fact tables will be in the denormalized state and dimension tables will be in the normalized state. Okay. Because dimension tables contains what? Distinct and specific purpose information, and fact tables contains the multi-purpose information. So by this we have done the data modeling basics. All these are the data modeling basics you need to know before starting the practical data modeling. So till now in the data modeling, we're done with the conceptuality. Right from today onwards, let's start the practical data modeling. So how to perform the data modeling in the Power BI, right? So before doing the data modeling in the Power BI, first of all, you need to know where are we going to do the data modeling. In Power BI, to perform the data modeling, we have a separate tab. We have a dedicated tab available. So I'm just opening Power BI. Perfect. Now in the main Power BI window, here we have a separate tab called as the model tab. Guys. This model tab is the place where we are going to do the data modeling. This model tab is the place where we are going to perform the data modeling. Okay. So now in Power BI, as we are going to perform the data modeling in the model tab, in how many different ways can we able to perform the data modeling? In Power BI, the data modeling we are going to perform in two ways. The two ways of doing the data modeling are number one, automatic way. and number two, manual way. So the two ways of doing the data modeling are number one, automatic way, and number two, manual way. So automatic way means what? Automatic way means what? If both the tables contains, so in order to perform the data modeling, what we need is we need to have a common column, guys. So as we discussed in the last session, to perform the data modeling, what is data modeling? Data modeling is all about adding the relationship between the two tables, right? In order to add the relationship between the two tables, we need a common column. We need a common column between the two tables. Or this common column is also called as the primary key and foreign key. So if we have the common column with the same name, then we could able to perform the data modeling in the automatic ways. So if both the tables contains common column with the same name and in the same case, then we no need to do any data modeling manually. So Power BI will automatically performs the data modeling. Whereas the second way of doing the data modeling is the manual way. So if both the tables contains common column with a different name or in the different case, if both the tables contains common column with the different name or in the different case, with a different name or in the different case, okay, or in the different case, then we need to perform here the data modeling in the manual way. Okay, perfect. So now with this, let's do the data modeling on our AW tables. We have a lot of AW tables we're having, right? So my task one is performing the data modeling on the AW tables we are having. So let's see how to perform the data modeling on all the AW tables we are having. I'm just going back to the Power BI. In the Power BI, so I'm just connecting to every AW table we are having. So using get data, I'm bringing in those CSV files. So I'm just clicking on text to CSV and then I'm connecting to the AW CSV files. So first the calendar, the data is looking perfectly all right. I'm using transform data. And then here I'm naming it as AW calendar. Right, again I'm bringing in the next file, customers. I'm naming it as AW customers. And then products. So I'm just connecting to each and every AW table. So AW products. And AW categories. And then AW subcategories. And then I'm connecting to AW territories. So all these are what? All these are the dimension tables. So what are the tables I connected till now? All these tables contains distinct and the specific purpose information, guys. So in the last session, as I said, always the dimension tables will be in the normalized form, right? As the dimension tables will be in the normalized form, each and every table contains what? Each and every table contains distinct and the specific purpose information. For example, this AW calendar contains just the dates information. AW customers contains the customers information, only customers information. And AW products contains what is AW products contains only the products information here. And then AW categories contains the categories information. Subcategories contains the subcategory information, and territories contains the territory information. So in these six tables, we got that distinct and specific purpose information. Those six tables are in the normalized form. And again, here we have got two fact tables. So the first fact table is the returns. So fact tables will be in which form? Fact tables will be in the denormalized form, where each and every fact table contains multi-purpose information. So I'm just bringing in the AW returns. If you see the returns here, in the AW returns, in the return table, we have the territory information, the territory key. This is a foreign key. We have territory key in the AW territories table. The same territory key is there in the returns table as well. And we have product information, and also we got date information. So here we got multi-purpose information. So this is in the denormalized form. This is AW returns. And again, we got the sales for 3 years, sales for 15, 16, and 17. So when I click on here, new source, when I click on text or CSV, let's see here we got sales for 3 years. I created remaining 3 files. The 3 years are 15, 16, and 17. So how to combine the data from these 3 years? These 3 files are having the same structure. In order to combine the data from multiple files having same structure, what we have to do? We need to perform
Append.
what? Appending.
Append.
So
Append.
what is the dynamic way to perform appending? We need to connect to the folder. So I'm just clicking on more. I'm just clicking on here more, and then I'm just connecting to the folder. So I'm just giving the folder path. So this folder is there in my C drive. Somewhere around. Yeah, in the data files, in the AWS CSV data files, I have it. I'm just clicking on OK, and then I'm clicking on OK. So now just I need to have only the sales files. How to get only sales files, guys? We need to click on here, transform data. So in transform data, I'm just here adding a filter on the name column, which includes only the Adventure Work sales. So I'm adding a filter on the name column. I'm just going to the name column. I'm going to text filters. I'm taking here a logic which text filters contains sales. So now it's just going to give us what, guys? Now it's just going to give us here all the files whose name contains here sales. I'm just clicking on OK. So now here we got all the sales files, and here more importantly we got the content column. All the remaining columns are of no use. So let's remove all the columns. Let's keep only the content column. How to keep only the content column? We have to right click on the content column, and then we have to click on remove other columns. Perfect. Now here we got the content column, and then here I'm using this combine option to perform appending of all these files. I'm just clicking on OK. So I'm just naming this as AW sales. Perfect. If you see here this AW sales, so all these things we are done. we done previously. Again, I'm just redoing the things again. You see the AWS sales data again. Here we got the data information. Here we got the product key. Here we got the customer key. Here we got the territory key, right? Again, it is having multi-purpose information. So again, AWS sales is a fact table. Always fact tables contains what? Always fact tables contains the multi-purpose information, and they will be in the denormalized form. Okay, and they will be in the denormalized form, right? So here I'm just clicking on close and apply. So I need to move all these tables to the main Power BI window. How to move all these tables to the main Power BI window? We need to just click on close and apply. Perfect. Now it's loading all the tables. So now you could see here all the 8 tables we're having, all those 8 tables will be loading into the first the model tab is. In the model tab, we could see here the relationship between some tables. If those two tables contains or if those tables contains the common column with the same name, we could see here the relationship here. Okay, see here. Right. So it is adding here the relationship in the automatic way. So here how it is adding the relationship in the automatic way. Here how it is adding the relationship in the automatic way means, for example, you could see here in between the returns to products, in between the returns to products, you're seeing a line. This line indicates a relationship line. It is adding a relationship because in between these two tables, when I click on that line, it is highlighting the common column. What is the common column between the products and the returns? The product key is the common column. As product key is the common column with the same name we are having, here Power BI is automatically adding the relationship. So why it is automatically adding the relationship is, if you go to your options and settings, once you go to your options, in options and settings, once go to your options, in options, so now under the current file, if you go to the data load, under the current file, if you go to the data load, here we have an option called as auto detect the new relationship after data is loaded. So once we load the data, here we have an option called as auto detect the new relationships. What this option gonna do is it will automatically detect the relationship between those two tables if those two tables contains common column with the same name. If you uncheck this, then it won't add the then it won't add those relationships, guys. But it's good to have. It's good to have this option checked. This is the by default. This option got checked. As a result, we are seeing here automatic relationships. So in between the products and the returns, we got automatic relationship because common column name is same. And again, in between the it is adding the relationship between the products and the subcategories because here the common column here it's same for the products and the subcategories. The common column here is the product subcategory key and product subcategory key. And again here the common column name is same product category key and product category key. And again, if you see here the AW products and the sales, here again there is a relationship between the products and the sales. The common column is product key, and in between the customers and the sales, the common column here is the customer key. The common column here is the customer key. You could see that, right? Perfect. So now like this, you could see here in between all the tables, here again the common column here is the product key and product key. So in all these tables, the common column name is same, and in the same case, it is adding the automatic relationship. It is not adding the relationship with the calendar. Right, here you might have a lot of doubts. So before clarifying all your doubts, in the data modeling, the best practice is take all your dimension tables in the top. Dimension tables are also called as what? Master tables. And the fact tables are also called as what? Transaction tables. As dimension tables are master tables acts as the parent, keep all your dimension tables in the top. So I'm taking here AW products into my top, AW calendar into my top, and AW subcategory into my top. Okay, AW customers also into top. Perfect. So just collapsing it. AW customers also I'm placing in the top. Subcategory also I'm placing in the top. So all these tables, as they're occupying space, we can just collapse them. Here we have an option called as collapse. If we collapse, it will show us only key columns. I'm just collapsing it. It will show us only key columns like this. Okay, perfect. AW categories are moving to the top. AW territories also moving to the top. Just moving all the dimension tables in the top row. Perfect. And all the fact tables, we have to place it in the bottom. Remember one thing, always all the dimension tables should be in the relationship with the fact table, guys. Here, there is no relationship between the calendar and the AW sales, and also AW territories and the AW sales. How to add the relationship? We can add a relationship in two ways. We can add the relationship in two ways. One way is directly in this relation window we can add, and the second way of adding the relationship is using the manage relationships. Using the manage relationships also we can add the relationship. So let's add the relationship first here. So here in between the calendar and the sales, the common column here is date, and in the AW sales, the common column here is order date, right? So the common column name is different. In order to add the relationship, I'm dragging date and I'm placing into the order date. So I'm adding the relationship like this. So now here we got the relationship between the calendar and the sales, right? Using date and order date. And also here we got the AW territories. Here we got the AW sales. So here the common column is sales territory key, and here common column is territory key, right? So we need to add the relationship between the AW territories and AW sales. Again, in order to add the relationship, we need to drag the sales territory key, and we have to drag and drop into the territory key. So we need to drag and drop common column from one table, and we have to drop it into common column in the other table. Like this, we need to add the relationship. This is one way of adding the manual relationships here. After adding the manual relationship, we got here the relationship line. Perfect. In the similar way, we need to add the relationship between the calendar and the returns, as well as territories and the returns. Okay. So how to add the relationship? The other way of adding the relationship is with the help of manage relationships. Just click on here, manage relationships. Once you click on manage relationships, here we have an option called as new. Once you click on new, here we can choose those tables. The table is AW calendar, and here the table is AW returns. So here the common column is date and the return date. And whenever you are adding the relationship here, it is asking for the cardinality. So cardinality, we no need to select or we no need to add it manually. cardinality, we no need to add it manually, guys. Power BI will automatically takes the cardinality. So AW calendar is the dimension table, AW returns is the fact table. So one date will have what multiple returns. As one date will have multiple returns, the cardinality is one to many. So good thing is Power BI will automatically take this cardinality. We no need to change this. You change also here, for example, I'm changing from one to many to one to one. To change that from one to many to one to one means it is giving an error. It is stating that it is invalid. So there should be one to many. So we no need to change or we no need to add the cardinality manually. Power BI will automatically takes it cardinality. This cardinality is we already discussed in the module 1 part 1, right, while doing merging. While discussing the merging queries, I discussed this cardinalities, right? And also here we got other two options, cross filter direction and make this relationship active. You'll come to know about this too. You will come to know about these two options, how these two options going to work, you'll come to know. So I'm just clicking on OK here. Perfect. And again, I'm just clicking on here, close. So now we have added the relationship between AW calendar and AW returns. AW calendar and the AW returns. Again, we need to add the relationship between AW territories and the AW returns as well. To add the relationship, again, go to here, manage relationships. Again, I'm just clicking on here, new. Now here, I'm just taking up here AW, what is that? AW territories, and then here AW returns. Right here, the common column is the sales territory key, and here the common column is the territory key. So again, after choosing here common column, we need to choose the common column like this. Again, it is automatically taking the cardinality, and then I'm just clicking on here, okay. So I'm just clicking on here, close. So now here again, we got the relationship between the AW territories and the AW returns. So like this, we are going to add the relationships case. So here you might get some doubt. So as I'm adding the relationship between the tables, so how to know to which table we need to add the relationship. Here the first doubt which might comes into your mind is, as I'm adding the relationship between these tables, how to know to which table we need to add the relationship. That is the first doubt. And the second doubt is, okay, in the relationship line here you're seeing something called as one and star. What one and star indicates? So this one and star indicates the cardinality is. This one and star indicates the cardinality. Always on the dimension table side, we have one. Always on the fact table side, we have many. See here, towards the returns and sales, as we got two fact tables, here we got stars. Usually dimension tables contains what? Primary keys. Fact table contains what? Foreign keys. So as the dimension table is acting as a parent, one parent can have multiple childs. Like that, one primary key can have multiple matching values in the foreign key, because foreign key allows what? Duplicates. As a result, here we got one too many. So this one and star indicates one too many. And here you're seeing some kind of arrow here. This arrow is also very, very important. This arrow indicates the filter flow, guys. That arrow indicates here the filter flow. So filter flow means like how the two tables are querying each other. This arrow indicates the filter flow. What filter flow indicates is how these two tables are querying each other. So I'll talk again about this filter flow later. Now, let's understand, let me answer that first question. How to know to which table we are going to link. So you need to remember that if you're working on any project in the real time, your backend team or your data model team will provide you the schema design. Just you need to use that schema design, and based on the schema design, you need to relate those tables. Okay, if they don't provide you any schema design, then it is your responsibility to get that schema design, or at least the common columns, how that schema design would look. So the schema design document going to look like this, guys. The schema design document going to look like this. So in between to one table to other table, they'll give the relationship. Based on the relationship, we need to redo the same thing in the Power BI. For example, here we got the relationship between the products and the suppliers. So here it gets the relationship line. And towards suppliers, you're seeing a key here. What this key indicates? Supplier contains the primary key. And towards the products, you're seeing some kind of M icon. What this M indicates is many. So it means it is having the foreign key. That is quite obvious because one supplier can supply about multiple products. One supplier can supply about multiple products. Cardinality is one to many. In suppliers table, either is having key column. The key column will be indicating the key here. The key column is what here? The supplier table, supplier ID. In the products table also we are having here supplier ID. So we need to relate these two tables, or we need to add the relationship between these two tables using supplier and supplier ID. But here, as the primary key and foreign key column names are same, we no need to add here relationship manually. Power BI will automatically take the relationship. Again, in between the categories and the products here, the key column here is the category ID. Right here, the key column is the same category ID is there here. It will automatically add the relationship, and the cardinality equals here one to many from categories to products. So if you see from the products to categories, it is many to one, and if you see from categories to product, it is one to many. Right, like this, we are going to get this relationship or the data schema diagram. Is based on this data schema diagram, based on this data schema or the relationship schema diagram, you need to create the same thing in the Power BI. This is the schema model diagram for the OData tables. Now, my second task is, my task 2, performing data modeling on the OData. How to perform data modeling on the OData? I'm just going back here to Power BI. I'm just bringing in all the OData tables. So as OData, we connected recently. If you go to the report tab, in the report tab, you got something called as recent sources. In recent sources, there might be a chance for the OData. Just click on here more. Just scrolling down. Looks like it's not there. No. Okay. Anyways, no issues. I'm just going to the web here. Then I'm just opening here Google, and then I'm looking for Northwind OData. Just opening your Northwind OData feed. And then I'm just clicking on the first link. Then I'm just copying the link. I'm just copying the link. I'm going back to the Power BI. Just clicking on get data. I'm just taking here OData feed. So using OData, I'm just connecting to the OData tables. All this you know, right? So in module 1 we discussed it. I'm just clicking on OK. So I'm just bringing in the OData, guys. All these tables we connected for most of the times in the module 1. Again, I'm just bringing in all our OData tables. So what are all the tables we need? What are all the tables we need now? We need products, we need suppliers. So let's bring in all these tables here. Products, suppliers. I think we have got employees, we have got categories. I think we got customers, we got order details, we got orders. Right, I think we got suppliers. Let's see once. So products I have taken, suppliers I have taken, order details I have taken, categories I have taken. I think the territories we need to take. Territories I'm taking here. Right, next employees I need to take. Employee territories I need to take orders. Let's take this three. Employees are taken. Orders are taken. Looks like we don't have employee territories. That's fine. One table or other is not available. We can just ignore that. Employee territories is not there. I'm just ignoring this table. Then customers, shippers. So customers, yeah, are taken. And shippers, I'm just taking it. And then customer demographics. Yeah, customer demographics is there. Yeah, this table is empty. Okay, that's fine. So I just pick all my required tables. In the O data, just pick all your required tables like this. Pick all your required tables like this. Just clicking on here, load. So now again here we are adding up what bunch of tables. You could see here. Again here we're loading up bunch of tables, guys. So where we need to perform data modeling in the model tab. Go to the model tab. In the model tab here we got all our AW tables, and again we have added here what the Northwind OData tables as well. So here one flexibility we have is we can here add a new tab. In the new tab we can take the required tables. I'm just clicking on here plus. I'm adding a new layout. I'm naming it as Northwind OData. Northwind OData. Okay. So here I'm just taking up the Northwind OData. Right? In Northwind OData, I'm just taking up here all my required tables. Just taking up here all my required tables here. So in the layout, we can add all our required tables. So what is the first table here? We're having the first table we are having is products and then suppliers. Just taking here products. And then I'm taking up here suppliers. See here, it is automatically adding the relationship between the products and suppliers because the common column name is same here, supplier ID and supplier ID. Just collapsing it. If we collapse it, it will just take the common column. See, the common column name is same. So collapse will just shows only the common columns. Perfect. So then after supplier ID, after products and the service, and then I'm taking here. I think I didn't take the region as well. Let's add the region also. I believe the region table is not there. So if you want to add any new table, again go to transform data for your O data tables. Just go to the source here. In the source, I'm just double clicking on the source step here and the navigation. So to add the region table, let's go to the advanced editor once. Not the customer demographics. So okay, once go to the source. Perfect. Let's do one thing. So again, I'm just connecting to the O data. Now for the O data, I'm just pasting here the URL again. So I forgot to add a new, I forgot to select the region table. Now I'm choosing that table. Then the list of tables we are having, I'm just choosing here the regions, just clicking on OK. Perfect. We got the regions information. I'm just clicking on here, close and apply. Perfect. So here I've taken products and suppliers, and then what is the next table here? So the next table is the categories. I need to bring in here categories. Let me take here the categories. So categories table should be in the relationship with was table. You could see here. Category table, it is in relationship with the products like this. Okay. So the key column here is ID, and here category ID. The thing is, we are not adding any relationship. What is happening? What is happening? The relationship is automatically coming here because the primary key and foreign key column names are same, right? And then what is the next one? The next one is order details. So in the order detail, the key column is on the product side. So here product ID is the key column, and in the order details, the product ID is there. Perfect. So they'll indicate that on which table you need to take the key column. The key column should be from the product side. So let's take your order details. So again, it is adding the relationship with the products and with the product ID and product ID, and here you got the relationship, right? And the next one is what? The next one is with the products. We got order details. So the order details, we need to take care about orders. Let's bring in the orders. So in between the order details and the orders, the key column is there on the order side. The key column here is order ID, and here order ID is there. So let's take your orders. Let's take your orders. Right, here again we got the order ID and order ID here. You could see that. So order ID and order ID here we have got the key column. Again, I'm adding a relationship between orders and the customers. Key column is there on the customer side. Here customer ID and customer ID. Let's take here customers. Just clicking on minus to reduce the, yeah. So in between the orders and the customers, again, here we got the relationship. Common column here is the customer ID and customer ID. And again, from the orders to the shippers, here again we have got the key column. Here shipper ID, and there also we got the shipper ID. Just taking here shippers. So here again we got the key column. The key column we got is the shipper ID, and here ship via. So let's take here the key column. Here shipper ID. Yeah, ship via. So here, even though the key column name is different, but Power BI is adding the relationship. So how Power BI is adding the relationship is, even though if the key column is different, The reason is, again, if you go to your file, if you go to your options and settings, if you go to your options, then again we have one more option. Once we go to the data load, in the data load, here you got one more option called as import the relationships from the data sources on the first load. So at your data source level, if there is a relationship automatically defined, at your data source level, if there is a relationship which has automatically defined, it is importing those relationships. So even though the key column name is different, whenever I drag and drop the second table, it is adding the relationship because that relationship has defined at the data source level. Okay, perfect. So what are the other tables we have? We have added relationship between shippers and this. And we need to add the relationship between the territories and the regions as well. So I think first we need to bring the territories as well. So territories, we need to join two employee territories, but this table is not there. So territories, we need to join to the regions. I need to bring these two tables. Regions I'm taking here. And territories I'm taking here. Again, we could see here the relationship here in between these two tables. We have got common column is the region ID and the region ID. I think we got all the columns. We got products, suppliers, order details, categories, territories, regions. We need to add the relationship between the employees and the orders. The key column is coming from the employees table. The key column is employee ID. And here also employee ID is there. Again, let's go back here to Power BI. Let's bring in here employees. So now here we got the relationship with the employee ID and the employee ID. All right. So now we have added the relationship in between all the tables, guys. So like this, you will get the data model diagram. In the data model diagram, you'll have all the relationships. You have all the key columns. Based on this, you need to recreate the same thing in the Power BI. So here you can drag and drop the relationship manually like this, or you can here use the manage relationships as well. So like this, we can add the relationship between the two tables, guys. Here, you might get one more doubt as well. The same thing we can do using the merging as well, right? In Power Query, we have the merge queries. In merge queries also, based on the cardinality between the two tables, in merge queries also based on the cardinality between the two tables, we're defining the merge type and we're getting the output, right? So what is the difference between merging the data and modeling the data is? Now we are modeling the data. The same thing we can do with the merging as well, right? So what is the difference between merging the data and modeling the data? So let's understand that. So now let's talk about what is the difference between merging the data and modeling the data. Because so now first what I will do is I will perform the merging of all the AW tables. Where we could do the where we could perform the merging of the data, guys? The data merging we can do in the Power Query, right? So I'm just opening here Power Query. In Power Query, I'm connecting to all the AW tables. So I'm just taking up here text or CSV, taking here AW calendar. Just clicking on OK. Then I'm just clicking on here new source, text to CSV, and then I'm just connected to the customers. So I'm just connecting to all the tables now. I'm just connecting to again here text to CSV. Just connecting to the categories. Connecting to products. And sales, we got data for 3 years. I'm just connecting to the folder. So I'm just connecting to all the sales files to perform dynamic appending. Just clicking on transform data. So I'm just including here all the sales files by adding a text filter whose name contains your sales. So we're connecting to the folder. On the folder, we are just getting all the sales files. Here I'm adding a condition. So now we got all the sales files. I'm just keeping content column and I'm removing other columns. Here I'm expanding the content. I'm naming it as here AWS sales. Perfect. So how to perform here merging is, we need to just go to merge queries and we have to go with merge queries as new. Right, to the AWS sales, I'm merging here AWS customers. So the common column here is customer key and customer key. In merging, you need to identify the cardinality manually, guys. But in modeling, we no need to identify cardinality manually. So the cardinality between here sales and customers is, so from one customer, we're going to get many sales, right? One customer can have what? One customer can have many sales. So the cardinality between the sales and the customers is the cardinality between here the sales and the customers is many to one. If it is many to one means we have to go with the left outer join. Just clicking on OK. Naming it as AW data. So currently here we're merging two tables, customer and the sales. I'm just expanding the right side table. And again to this tables, okay. And again to this tables here I'm merging the AW products. Okay, to the AW data, I'm merging the AW products. So I'm just going back to AW data. I'm going to merge queries. Merge queries here I'm choosing because the same table I would like to merge. So in the AW data, I'm merging here AW products. I'm taking here the product key and the product key. So the cardinality is again one product going to have many sales. So it is again many to one. The join type is left outer. So in the merging, we need to choose here the cardinality manually. But in the modeling, the advantage is Power BI is automatically giving us the data modeling. And here we got the third table. What merging is doing is, merging is taking all the tables into one single table. In the merge result, we got all the table merging output we got into one single table. So we got the sales, we merged with the products, we merged with the customers, and let's merge the calendar as well. Just taking here merge queries. Taking here date and the order date. So it is -1 left out. Let me stop loading all these tables. I'm just right clicking here. I'm unchecking enable load. Customers unchecking enable load. Categories unchecking enable load. Products unchecking enable load. So I'm just taking here only the AW data. I'm stop loading all these tables because this is the merging of all the tables. Just clicking on close and apply. Right, now it has loaded the data. Now you could see in the merged table, a single table is having here all the columns. A single table is having all the columns. So in the merging, what is going to happen is the data will be in the denormalized form because the table contains multi-purpose information. Table contains the date information, table contains the products information, table contains the customers information, table contains the territory information. So in the merged output, the table going to have all the information. So a single table going to have everything. Whereas in the data modeling, after modeling also, once you go to the data window, after modeling also, once you go to the data window, now what's going to happen is the table structure remains same. See here, in the data modeling, we performed modeling of all the AW tables. So AW calendar, it got model or it got in relation with AW returns and AW sales. After adding the relationship, once we go to the data window, so after modeling, the next tab is the data tab. Guys, we'll go to the data tab. In the data tab, once you click on AW calendar, we're just seeing here the calendar information. If you go to the AW sales, we are just seeing up here the AW sales information. If you go to the AW territories, we're seeing up here the territory information. We go to the product categories, we're seeing up here the category information. Subcategories, we're seeing up here subcategory information. So every table structure remains same in the data modeling. So the difference between modeling and merging is, the difference between modeling and merging the data is, so modeling the data and again merging the data. So data modeling is a logical join. It's not physical join. It's not combining the tables physically. So it is logical way of combining the data. Whereas merging the data is the physical way of combining the data. So the data modeling is a logical join, whereas merging is a physical join. And in the data modeling, the table structure remains same. Whereas in merging, what's going to happen is all the tables got merged to merged into a single table. So in the merging, the main drawback is for example, if you go to this merging, so I'm just taking up here from the AW calendar, I'm just taking up here date. From the AW calendar, I'm just taking up here the date. And I'm taking up here the order quantity. Right. As here, I've taken up here the date. Now what the Power BI going to do is, so the Power BI will go back to the data. It's just going to query the date column. Now I'm talking about in the merging. It will query the date column. Where is the date? Yeah. So it will query the date column. This date column is having how many values? This date column is having 56,000 values. So now the Power BI going to query the 56,000 values, and also I have taken order quantity. So order quantity is having how many values? So here, this order quantity is also having 56,000 values. So as in the report, I have taken here, the date and order quantity. Now Power BI going to query 56,000 values for each and every column. But how many values actually we are having in the data? Once go back to the Power Query. In the Power Query, date is coming from the AW calendar. Date is coming from the AW calendar. If you see here, this AW calendar date column is having how many rows? This date column AW calendar is having only 912 rows. 912 rows. But after merging the data, what is happening? After merging the data, now this date is coming in 50,000 rows. Because merging is a physical join, it is combining both the tables into one single table. So AW calendar is just having 912 rows. It is merging with AW sales. AW sales is having, let me count the rows. AW sales is having here 56,058 rows. They are taken right join. Right join means complete data from the right table, right? So it is giving us 56,058 rows for the calendar table as well. For the calendar table as well. As a result, what is happening? The data is duplicating. So in the merging, we are getting the data duplicates. What about in modeling? In modeling, let's go back. In modeling, I'm again creating a report. Now from the AW calendar, I'm just taking the date. I'm just taking here the date, and from the AWS sales, I'm taking here order quantity. So here I'm taking date from the AWS calendar. AWS calendar is having how many rows? AWS calendar is having, if you click on AWS calendar is having here 912 rows, and AWS sales is having here 56,000 rows. So now what Power BI is going to do is it will make the query to query only 912 rows on the AWS calendar and 56 AWS sales. So for the AWS calendar, it's not creating any data duplicates. For the AWS calendar, it just keeping up the original data as it is. The main advantage with the data modeling is no data duplicates. No data duplicates, because in the modeling the table structure remains same. So in the modeling the data, tables will be in the normalized form, whereas in the merging the data, tables will be in the denormalized form. Tables will be in the denormalized form. As tables will be in the normalized form in modeling the data, so no data duplicates. No data duplicates. Whereas in merging the data, we're getting what? We're getting the data duplicates. And also, as there is no data duplicates in the modeling, queries will run faster. Queries will run faster. Whereas in the merging, as we're getting the duplicates, queries will take time to execute, or queries will run slower. So as a result, modeling the data gives very good performance. Whereas in merging the data, it gives less performance. Okay, and in modeling the data, cardinalities are automatic. Whereas in modeling the data, cardinalities are what? Cardinalities we need to identify manually. So these are the differences between merging and modeling the data. So now, which is the better way? Which is the preferable way is in order to combine the data from multiple tables? To combine the data from multiple tables, which is the better way? Is merging the better way or modeling is the better way?
Modeling, sir.
Always data modeling is the best option. So whenever you're trying to add the data from multiple tables means, and always the best practice is data modeling. So data modeling is the best way to combine the data from multiple tables. To combine the data from multiple tables, data modeling is the best way. Right? Perfect. So this is the difference between merging the data and modeling the data. All right. Next, the next concept is types of relationships. The next concept is types of relationships. In between any two tables, two types of relationships will exist, guys. In between any two tables, two types of relationships will exist. Number one, active relationship. And number two, inactive relationship. So in between any two tables, two types of relationships will exist. The two types of relationships are number one, active relationship, and number two, inactive relationship. Number two, inactive relationship. So what is an active relationship? So in between any two tables, we can add n number of relationships, guys. In between any two tables, we can add n number of relationships. Out of this n number of relationships, only one relationship will be in the active mode and all the remaining relationships will be in the inactive mode, right? The point is, in between two tables in the Power BI, we can add n number of relationships. In that n number of relationships, only one relationship will be in the active mode and all the remaining relationships will be in the inactive mode. Okay, active relationship means whenever Tableau is executing any query between the tables, it will use that active relationship. Inactive relationship means, as the name itself is telling, the relationship is in the inactive mode. As it is in the inactive mode, it won't uses that relationship. Just we can add it, but that relationship is in the inactive mode. Okay, let's understand this in a better way. I'm just going back to the Power BI where we performed the data modeling. Here I'm adding a new tab. Now in the new tab, what I'm doing is I'm just taking here AW calendar table and I'm taking here AW sales table. I'm taking here AW calendar table and I'm taking here AW sales table. Now here you could see there's a relationship line between AW calendar and the AW sales. It is adding the relationship between the date and the order date. It is adding the relationship between the date and the order date, right? So now again I'm adding the relationship between date and the stock date. I'm taking here the date and I'm adding relationship with the stock date. So now I'm trying to here add the second relationship between the date and the stock date. See here, after adding the relationship between the date and the stock date, you can see here in between the date and the stock date, you got line with the dots, we got a dotted line, and in between the date and the order date, which we have added already, we got here a continuous line. So this continuous line indicates the active relationship. This dotted line indicates the inactive relationships. So always inactive relationships will be indicated with the dotted lines, right? But whenever whenever Power BI is firing any query here, it means if you're creating any visual on these two tables, so I'm just taking here date from the calendar, I'm taking order quantity from the AW sales. In order to get the data from these two tables, it will make use of the relationship. So which relationship here Power BI will make use of here is, it will make use of the active relationship. It will always compute on the active relationship, right? So now, is it possible to convert active relationship to inactive and inactive relationship to active or not? Yes, we can do that. We can convert active relationship to inactive and again inactive relationship to active also. How to do that? Just double click on that relationship line. Once you double click on the relationship line, it will open up here the relationship window. Now in this relationship window, here we have an option called as here we are having an option called as make this relationship active. This option will make the relationship active. This option will make the relationship inactive. So currently this relationship is active. If you want to make it inactive, just uncheck it. When uncheck it, what's going to happen is here Power BI will automatically convert this relationship to inactive. Just clicking on OK. Now this relationship has turned to inactive. Now you could see here both are indicating with the dotted lines. What the dotted lines indicates, these two are inactive relationships. Again, to convert this inactive to active, just double click on this inactive relationship. And to make this as active, just check this box. When I check this box, it is making this a relationship to active. So here we're turning active to inactive and inactive to active like this, right? So in between any two tables, we can add what? We can add multiple relationships. As we can add multiple relationships, one relationship will be in the active mode and other relationships will be in the inactive mode. Perfect, right. In the last session, we performed the modeling on AW tables. We did modeling on all the tables here on the AW tables, and we have taken all the dimension tables in the top and fact tables below. All the measure tables below. As we got all the measure tables below, so here the most important point is all the dimension tables are in communication with the fact table. All the dimension tables are in communication with the fact table like this. There is no direct relationship or there is no direct communication between two fact tables. There is no direct relationship or there is no direct communication between the two fact tables. One common question is, can we directly relate two fact tables or not? Or can we directly connect two fact tables or not? Right? One common question for everyone is, can you directly connect two fact tables or not? Here we haven't connected, even though that is not recommended as well. But let's answer this question. And in fact, there is one very important interview question as well. So connecting multiple fact tables directly, this is not at all recommended. Why it is not recommended, you'll come to know, because it creates duplicates. So connecting multiple fact tables directly, or it is also called as handling many to many relationships. Because if we connect two fact tables contains what? Foreign keys. If you directly relate two fact tables going to create many to many relationships case. This is the most important interview question and most important concept in the real time. How to handle many to many relationships in Power BI. And also they'll ask when many to many relationships will come in Power BI. So when many to many relationship will comes in the Power BI is we're directly connecting two fact tables or directly connecting two foreign keys. Then Power BI going to create the many to many relationships. So first let's understand the problem statement and then we'll go for the solution. To understand this problem statement, I'm just creating two simple tables. So the first table here I'm creating is, let's say, cars produced. Here I'm taking manufacturer, year, and let's say I'm taking their cars sold. So let's say I'm taking here manufacturer as Maruti, the year as 2020. They sold, let's say, some 50,000 cars. Again, I'm taking here Maruti 2021. They sold 60,000 cars. Then I'm taking here Hyundai. Okay, I'm just taking it two manufacturers. And they sold here, let's say, some 40,000 cars and 55,000 cars. Okay, so this is the first table I'm having, this car sold table. In car sold table, we have here multi-purpose information. We got the manufacturer information, we got the year information, also we got the car sold. So again, I'm taking here one more table, cars produced. So let's say they produced some 60,000 cars in 2020 and 71 cars. They produced some 35,000 cars. Okay, 65,000 cars, right? So here I'm having two simple tables, guys. The two simple tables are, one is the cards. Now, let me recap what I was talking. So the next concept is how to handle many-to-many relationships in the Power BI, or can you directly connect two fact tables directly or not. So we can connect two fact tables directly, but the problem is if we connect two fact tables direct, it will create many-to-many relationships. So that many-to-many relationships will create duplicates in the data. Let's understand that with an example. To understand the problem statement, I'm just taking here two tables case. The first table is the car sold table. In the car sold table, I'm just taking here three columns. One is the manufacturer, second one is the year, third one is the car sold. And also I'm taking here cars produced table. In the cars produced table, I'm taking here again three columns. One is manufacturer, second is year, and third is cars produced. So I'm just taking here three columns of data in each and every file. So from Power BI, let me connect to it. Let me go back to Power BI. All right. So now here I'm just connecting to those two tables. First one is the cars produced. Right. I'm just loading it. And second one is the cars sold. Just loading it again. Just going to the modeling tab. In the modeling tab, I'm taking here cars produced and I'm taking here cars sold. Okay. So now what I'm doing is in between the two tables here we got manufacturer and manufacturer common column is there, or year and year common column is there. You can use any of these common columns. It doesn't matter. So I'm linking this to, even though common column is there, you could see here Power BI is not adding the automatic relationship. So even though we have the common column with the same name and in the same case, but still Power BI is not adding the automatic relationship. The reason why Power BI is not adding the automatic relationship is because there is a many-to-many relationship between these two tables. Okay. So now I'm just taking here manufacturer from the cars produced. I'm placing manufacturer into the cars sold table. See here, when I'm trying to add the relationship between these two tables, okay. So now here, what happened is, so it is just creating here, the cardinality as many to many. Cardinality as here many to many, and it is giving here a warning. The warning it says is this relationship has cardinality many to many. Whatever the relationship we are adding, this relationship is having the cardinality many to many. So there is a many to many cardinality between these two tables, guys. As there is a many to many cardinality between the two tables, what it is stating is, first of all, why we got many to many? Why we got many to many? Because we're adding your manufacturer to the manufacturer, right? So every value in each table is having multiple matching values. For example, the first value here is Maruti. Maruti is having here multiple matching values. This Maruti matching. Again, this Maruti matching. Similarly, if you take this Maruti is having again two matching values. So every value in a table is having multiple matching values in the other table. So one value in this table is having multiple matching values in the second table. Again, one value in the second table is also having multiple matching values in the first table. thus it is creating many-to-many relationship between these tables. Okay. So as the cardinality is many-to-many, what it is stating is this should only be used if it is expected that neither column manufacturer and manufacturer contains unique values. So when it is going to create the many-to-many is in the common column, if there are no unique values, so then it will create what many-to-many. Okay, and the many-to-many will create a problem. What problem it just going to create? Make sure here cardinality is what many-to-many because we're trying to link both the fact tables directly. So I'm just clicking on here, okay. So I'm linking these two fact tables directly, guys. Now what I'm doing is I'm going to create now a report. Now I'm creating a report. Now in the report, I'm taking here cars produced. I'm taking here year. Here it is taking sum of year, I mean it is aggregating year. I don't want to aggregate year. I'm just moving this year to, I'm just taking it as a table. In the visualizations, we have different types. I'm just taking it as a table. Okay, and here I'm not aggregating. Just taking in the don't summarize means actually yes, I'm taking here years first, and then I'm taking cards sold. So the cards produced, and then I'm taking here cards sold as well. Now you could see the report here. It is showing up in the year 2021. The cards produced is 1,35,000 and cards sold is 2,05,000, right? So we have taken year and cards produced from the cards produced table. We have taken here year and cards produced from the cards produced table and cards sold from the other table. And we have taken here cards sold from the other table. Okay. So we are taking the data from two different tables. So now, just going back to the data, how many cards they sold in 2020 and 2021? It's showing here like in 2021, cards sold us 2,05,000. How many cards they sold in 2021, guys? 60,000 plus 55,000. So 1,15,000. They sold only 1,15,000 cards, but it's showing here 2,05,000 cards, which is wrong. In 2020, they sold 50,000 plus 40,000, 90,000 cars they sold in 2020. But how many it's showing here again 2,05,000, which is again wrong, right? So what is happening is the data is duplicating and it is giving us the 2,05,000 cars from the other table. So here we're taking the data from two different tables. So from the cars produced table, we have taken the data, and from the cars sold, we have taken the data. So whenever the data we are getting from the cars sold, from the cars sold table, we're getting here duplicated values. So as a result, at the end, what we're getting here wrong outputs. This is wrong. Whereas in the cars produced, as we have taken year and car produced on the same table, these numbers will be correct. But if you take the column from the other table, we're getting here the wrong numbers. So once go to cards produced, in the cards produced, as you could see here in 2020, we got 50,000 plus 40,000. So we got here again in cards, sorry, not cards, but cards produced. In 2020, 60,000 and again 35,000, 95,000. Yes, this is the correct value. And in 2021, 70,000 plus 65,000, 135,000. So both the data are from the same table, year and car produced. We have taken from the same table, these numbers are correct. But we introduce the column from the other table, it is duplicating. This is the main problem with the many-to-many. If you have many-to-many relationship between the two tables, then what's going to happen is whenever we take the column from two different tables, so the data will duplicate from the second table. So eventually what the output contains the wrong numbers. Then how to handle many-to-many? Then how to handle this many-to-many is, as you could see here, star on both the ends. The star indicates there is a many-to-many relationship on both the tables. There is a many-to-many relationship on both the tables. As there is a many-to-many relationship on both the tables, the best way to handle many-to-many is just just divide this many-to-many to many-to-one and one-to-many. Divide this many-to-many to many-to-one and one-to-many. Okay. So we need to introduce the dimension tables between these tables. We need to introduce the dimension tables between these tables. So what I'm doing is I'm just creating here two dimension tables. So I'm just taking here enter data, and then I'm taking here first manufacturer table. In the manufacturer table, I'm taking here manufacturer ID and the manufacturer name. So manufacturer ID is 1, the name is Marty. Manufacturer ID is 2, the name is Hyundai. And then I'm creating a year table as well. In the year table, I'm taking here my list of years. So I'm just taking it 2020 and 2021. So I'm just taking here dimension tables. Now remove the direct relationship between these two tables. So how to remove the relationship between these two tables? We need to right click on this and we need to just click on delete. Then I'm taking here manufacturer table and also I'm taking here year table. Okay. So in between the cars produced and in between the cars sold. So here we have got, so there is a relationship between the name and the manufacturer, and also it's not adding the relationship between the name and the manufacturer. So I'll explain why. I'll just remove this relationship. I'll just change this relationship to active. I'm just double clicking on it. I'm making this relationship as active. Okay. And then, so as you could see here, we got the relationship between the manufacturer from the cars produced, and again manufacturer and manufacturer from the cars sold. Again, I'm adding the relationship between the year from year to cars produced, and again year to cars sold. Right. Year to cars sold. Now here you could see we got the relationship between year to cars produced and year to cars sold. So now let me create the report by taking here year from the year table. As you could see here, from year to cars produced and years to cars sold, we got the cardinality as one to many. Because in the year table, this year is having unique values. In the year table, the year is having unique values. As year is having unique values, this year is in relationship with the cars producer. So every year is having multiple matching values here, and with the cars sold, every year is having multiple matching values here. So here there is one to many, and again here there is one to many, right? So as a result, now we can take the report from, now we can create report on this tables case. Just going into the report view. Now in the report view, so as here we got 4 tables. Now I would like to take year. When I search with the year column here, so year data we are getting from cars produced, cars sold, and year table. As you could see here, the year column is there in the year table. In the year table, year column is acting as the primary key. And in the fact table, cars produced, year is acting as the foreign key. In the cars sold, year is acting as the foreign key. So always a good practice is take the primary keys. So as we don't use the foreign keys, we can hide these foreign keys from the reporting tab keys. So for the year column, here we have an option to hide. I'm hiding the year column. Always a good practice in the data modeling is hide the foreign keys from the fact tables. This here is a foreign key, I'm hiding it. And manufacturer is also a foreign key, I'm hiding it. Again, manufacturer is a foreign key, I'm hiding it. Just for time being, I'll stop loading this AW data as well. For AW data, I'll stop loading this as well. Disabling the load. I'm disabling the load for the AW data as well here. Right. Now I'm going to the report tab. Here, when search for year column here, the year column is showing only from year table. Okay. And because in the modeling tab, we got year here, but year we have hidden. When you click on the eye icon means what it will do is it will hide this column from the, report tab. Okay. Now I'm creating a new report again. I'm just taking here year. I'm just taking here year, and I'm going to cars produced. I'm taking here cars produced, and I'm going to cars sold. I'm taking here cars sold. So as you could see here, we have taken the year from the year table, cars sold from the cars sold table, and cars produced from the cars produced table. Then what we have got is we got here blank. We haven't got any data. So something wrong with our modeling. We'll just fix that. So year and year. Okay, here the year got linked with the, just let me double click on the relationship here. Year got linked with the car sold, not car sold. The common column should be very careful, guys. Here I'm linking with the year table, year column only. Just clicking on OK. Right. The reason why we are not getting the data is year got linked to car sold column, which is a wrong column, right? Now here I'm linking with the year column directly. So I'm just going into the report tab. Now here now, as you could see, so for the cars sold, I'm just taking his sum. Now we got these numbers. So as you could see here, we got 3 tables in our data. The first table is the year table. From the year table, we have taken the year values. We got 2 years. And from the cars sold, we have taken the cars sold numbers. And from the cars produced, we have taken the cars produced numbers. So we are taking the data from 3 different tables. So now here, how is the result? Have you got any duplicates? Let's compare. So in the year 2020, showing cars sold as 90,000. So in 2020, how many cars sold? 50,000 plus 40,000, 90,000. Yes, that is correct. And in 2021, 60,000 plus 55,000, 1,15,000. These two numbers are correct. And how many cars produced? How many cars produced? So in 2020, 60,000 plus 35,000, 95,000. In 2021, 70,000 plus 65,000, 1,35,000. So these two numbers are exactly matching or not? Now have we got any duplicates? No, right? If we link both the tables directly, what happened? If we directly relate the two fact tables, what is happening? If we directly relate the two fact tables, it is creating what? Many-to-many relationships. So what is the problem with the many-to-many relationship? The main problem with the many-to-many relationship is what it is creating duplicates. Output contains wrong values. So then how to handle that? If you have any many-to-many relationship means, then always the good practice is divide that many to one and one to many. See here we divide that many to one and one to many. Again, the many to many we divided to many to one and one to many. Right. This is how we are going to decompose many to many relationships in the Power BI. Okay. So, and again, always a good practice is hide all the foreign keys in the fact tables, because whenever we're creating the reports, we're going to use the primary keys. So now the one final thing for the today's session is I'm going back to all the AW tables we're having and I'm hiding all the foreign keys. This product key is a foreign key, I'm hiding it. When we hide the column here, it won't be visible in the reporting layer, in the reporting tab. I'm hiding the return date as well. I'm hiding the territory key as well. And I'm going to the AWS sales. Customer key is a foreign key. I'm hiding the foreign keys. Order date is a foreign key. I'm hiding the foreign keys. And this product key is a foreign key. I'm hiding the foreign keys. Stock date is a foreign key. I'm hiding this foreign key. Territory key is a foreign key. I'm hiding the foreign keys. I'm just hiding up here all the foreign keys. Right? This is a good practice. Now, as a result, whenever you go to your reporting tab, when you search for customer key here, customer key is available from the dimension table. You could see here from the AWS customers, you could see the customer key. It won't show us the customer key from the AWS sales. Right? This is a good practice. So we are about to complete the data modeling. In the data modeling, let's recap what we have discussed till now. So in the practical data modeling, we discussed about how to add the relationship between the tables, right? And then if you have a data model diagram or the data model schema, so using that schema, how to connect the two tables. And also we discussed about how to connect two fact tables. Is it a good step or is it a good practice or not, or how to handle many to many relationships. And also we discussed about how to hide the foreign keys. And also we discussed about difference between merging queries and modeling the data. So which offers the best performance? Is merging gives us the good performance or modeling gives us the good performance? So in merging, the problem is you just combine all the columns into one single merged table in the denormalized form, which creates the data duplicates. But in the modeling, the table structure will remain same and we don't get any data duplicates because modeling gives the table to be in the normalized form. As a result, modeling keeps the table structure intact as it is. So as a result, in modeling of the data, the tables won't have any duplicates and the queries will run faster. Whereas in merging, the table contains duplicates and queries will take some time to run. So merging gives the bad performance when compared with the modeling, right? Perfect. So In between two tables, as we added the relationship, how many types of relationship exist between two tables, guys? How many types of relationship exist between two tables? In between two
That's
tables, there are two types of
five
relationship going to
types.
exist, either active or inactive. What is active and what is inactive? So active means whenever we are taking the data from two different tables, Power BI uses the active relationship between the tables to fetch the data. Whereas inactive means whenever we are fetching the data from two tables, it won't use it inactive. It is just in the inactive mode. Even though we can add n number of relationships between the two tables, only one relationship will be in the active and all the remaining will be in the inactive mode, right? So the last concept in the data modeling is this cross filter direction. Cross filter direction. So let's understand what exactly this cross filter direction is. So today, let's talk about this cross filter direction. This is the last concept in the data modeling. So this is called as the cross filter direction, or this is also called as the filter flow. This is called as the cross filter direction, or it is also called as the filter flow. So filter flow, it defines how two tables going to query each other. Filter flow, it defines how two tables can query each other. Or cross filter direction, it defines how two tables can query each other. This cross filter direction or in this filter flow, we are having two values or we're having two types. This cross filter direction is of two types. Number one, single, and number two, both. So this cross filter direction is of two types. The two types are number one, single, and number two, both. So what is this single cross filter direction and what is this both cross filter direction? So in between the two tables, if you have a relationship, in the relationship line, we'll see this upward triangle or we'll see this downward triangle, right? This downward triangle indicates the filter flow. Okay, so what exactly this single or what exactly this both corner doors, it just defines how two table going to talk to each other. It's just going to define how two table going to talk to each other. So here this cross filter direction is pointing in the downward way. It is also called as the one-way filter. One-way filter. Okay. So or one-way stream. So what exactly this one-way filter is? What exactly this one-way filter gonna do is, or what exactly single cross filter direction gonna do is, so the manufacturer table can filter the cars produced. This manufacturer table can filter the cars produced, whereas cars producer cannot filter the manufacturer. What this one-way filter gonna do is, this one-way filter allows manufacturer table to filter the cars produced, but cars producer table cannot filter the manufacturer table. It means dimension table can filter the fact table, but fact table cannot filter the dimension table. That is the definition of the single or one-way filter, right? I'm just double clicking on the relationship line and then I'm changing here this cross filter direction to both. When I change here cross filter direction to both means, let me click on OK. Now you will see here two arrows. One is the downstream arrow, other one is the upstream arrow here. So here we got two-way filters, the downstream filter and the upstream filter. So what this two-way filter gonna do is, this two-way filter, it makes manufacturer table to filter the cars producer table, and again cars producer table also can filter the manufacturer table. So the dimension table can filter the fact table, and again the fact table also can filter the dimension table. So the cross filter direction to both, it makes two tables to query each other. As a result, two-way filters will increases the number of queries. As a result, the two-way filters will increases the number of queries. So it's the reason we generally don't use this two-way filters in real time. Two-way filters will creates the complex queries, more expensive queries. As a result, we are going to avoid them. Okay. So the point is, the single is also called as the one-way filter. The single is also called as the one-way filter, and also we got both. So both is also called as the two-way filter. So one-way filter means dimension table can filter the measure table. Two-way filter means dimension table can filter the measure table as well as measure table can filter the dimension table. So let's understand that with an example. So I'm just taking here on the AW tables as we have not here. So I'm just going to my modeling tab. I'm adding a new layout here. The new layout, I'm just taking here AW territories table, and also I'm taking here AW sales, which is my fact table. Okay, and also I'm just taking here my AW returns. So I'm taking here AW territories, AW sales, and AW returns. Right. Here the relationship line is the based on territory key and sales territory key. So now the relationship as we already added. So by default here, what is the filter direction? The filter direction is pointing downwards. Means it is showing up only in one way. It is not showing up in two way. The filter flow is pointing towards the fact table. It is a one-way filter. I'm hiding this common column as well. The common column is the territory key. So the reason why the cross filter direction is one way is because one way filter gives us very good performance. The reason why the cross filter direction is always set to single default is the cross filter direction is single means it gives us very good performance. Okay, so now what I'm doing is now from the territory table, I'm taking here sales territory key, and I'm taking here order quantity, and I'm taking here the return quantity. I'll put now with these three columns. I'm creating a report. In the report, I'm taking here the sales territory key, and from the AWS sales, I'm taking here the order quantity, and from the AWS returns, I'm taking here the return quantity, and then I'm taking here as a table. Perfect. So now what I have taken is I have taken here the territory key from the sales territory key from the AW territories table, and I have taken order quantity from the AW sales table and a return quantity from the AW returns table. Now you could see here for every territory key, we are seeing the total order quantity and we are seeing a total return quantity. So the values have got filtered. So the total return quantity is 1828. This 1828 it got filtered down for every territory key. So from the territory key 1 we got 270. Territory 2 and 3 there is no return quantity. For 4 we got 362. For 5 we got one like that. For every territory key we have got here some return quantity, and for every territory we got here some order quantity as well. Perfect. So once we go to the model tab here, in the modeling tab, as you could see here, what exactly happening is this territory key filter is flowing towards the sales. This territory key filter is flowing towards the returns, and based on every territory key, it is getting the order quantity, and based on every territory key, it is getting the return quantity. So as I've taken territory key from the dimension table. The dimension table is filtering to both the measure tables. Now you might get one note here. What would happen if I take the territory key from the AW sales? Now I would like to take the territory key from the AW sales. Okay, how to take the territory key from the AW sales? Just go here. Now I'm taking here a report. I'm taking a territory key from AWS sales, and I'm taking here the order quantity, and I'm taking here the return quantity from the AWS returns. So I'm just using here expand table option. Now you could see here what exactly happened here. Now, as I've taken territory key from AWS sales, it is showing up every territory key, and the order quantity is getting filtered. The total order quantity is 84,000. It is getting filtered here for every territory key. But as you could see here for the return quantity, it is showing up the same return quantity 1828 for every territory key. So the total it is showing up here for every territory key. The total it is showing up here for every territory key. It is not filtering. It is not filtering here. Why it is not filtering? The reason why it is not filtering is here, as I have taken the territory key from the AW sales and order quantity from the AW sales, as both belongs to same table for every territory key. For example, territory key 1. For territory key 1, we got the order quantity. But the return quantity we have taken from the AW returns table. So that this territory key filter is not flowing towards the AW returns. So it means here AW sales cannot filter here AW returns. As a result, as this territory key cannot filter the AW returns, it is showing up the grand total for the territory key 1. Similarly, for territory key 2, it cannot filter, it is showing up the grand total. Like that, for the 10 territory keys from 1 to 10, you could see from territory key from 1 to territory key 10, it is showing up the grand total 1828 in every row. Why it is not filtering means because that filter is not flowing. This AW sales filter is not flowing towards the AW returns. So how to make this filter to flow? So how to make this filter to flow is, so we need to change this from unidirectional to bidirectional filter. Just double clicking on it. The current filter is single. Single means one-way filter or unidirectional filter. Now I'm changing to two-way filter or bidirectional filter. So bidirectional filter means setting the cross filter to both. Just click on OK. Now here I made this filter flow as two-way filter. As I made this filter flow as two-way filter, what going to happen is now the sales can filter the territories, right? These two filters can talk to each other. Now, as I have taken territory key, this territory key can filter the territories, and again the territory can filter what the returns. This is something like A can filter B, A is filtering B, B is filtering C, means indirectly there is a filter path between A to C. There is no direct filter, but indirectly there is a filter path between A to C. Okay, so once you go to the report tab here, now after making here the filter flow as both or bidirectional, now you could see here this 1828 it got filtered down. This 1828 it got filtered down here for each and every territory key. So that value got filtered down here for each and every territory key like this, right? Whereas now I'm taking the territory key this time from AW returns. I'm taking the territory key this time from AW returns. Okay, let me take here, I'm creating now a new table again. I'm taking the territory key from AW returns. Now let's see here I've taken the territory key from the AW returns. Let's see now what happened. Now it is filtering out the return quantity. Now it is filtering out the return quantity, but it is not filtering out the order count. Why it is not filtering out the order quantity? Because now the territories, now the returns is not filtering here what? Sales. So as I have taken the territory key from the returns and the return quantity from the returns, and we have taken the order quantity from the sales. So the territory has to filter what? The sales. But it is not filtering like that. Why it is not filtering like that? The reason is the filter is not flowing towards the sales. The filter is not flowing towards the sales. Okay, the filter is just a one-way filter, means territories can filter the returns, but returns cannot filter the territories. To make this returns to filter the sales, we need to turn this cross filter direction to both. I'm changing here the cross filter direction to both. Okay. Now you could see here the relationship you're creating, okay, filter AW territories by products, but only one filtering path between the tables in a data modeling is allowed. Deactivate existing relationship between the tables or change the filtering direction. So when I'm trying to here, what it is stating is when I'm trying to add here multiple bidirectional filters, it is giving us an error stating that if we create multiple bidirectional filters, it will add unnecessary filter paths, which is not allowed. So it is stating that this relationship can be added as only one-way filter. So this two-way filters are always expensive. These two-way filters are always expensive. So the reason we never use this two-way filters. Always we are going to use the one-way filters only. When do we need this two-way filters is if you want to take any foreign keys. But as I said yesterday, we always going to hide the foreign keys. If you hide the foreign keys, then there is no need of taking this territory keys. We can directly take the primary keys. If you want to take any primary key column and if you want to filter out based on that, if you want to take foreign key column and if you want to filter out based on that foreign key column, then we need to have this two-way filters. So, but never ever use this two-way filters because this two-way filters will create some unnecessary queries at the background which will going to impact the performance. So in real time, we never use this two-way filters or cross fill direction to both. We never use it. We always set the cross fill direction to single. Only if it is not required, then only we are going to set this cross fill direction to both. But that is a rare case in the real time. So we always set the cross fill direction to single, right? This is the filter flow. So always a thumb rule is never ever use two-way filters, guys. Because whenever you do the data modeling on the real-time data, always two-way filters going to impact your performance. It is going to degrade your performance like anything. So never ever use two-way filters. When do we need this two-way filters is if you want to take any foreign key columns, but we never take any foreign key columns, hide the foreign key columns. So whatever the data we have in the primary key, the same data will be available in the foreign keys. As the primary keys are part of the dimension tables, take the key from the dimension tables, and by default dimension table can filter what? The measure table. Does the dimension table contains more amount of data or measure table contains more amount of data? Which table
Measure
contains
contains
more
more.
amount of data?
Measure
The
contains more
measure
amount
table
of data.
contains more amount of data. If you take the data from the measure table, Power BI needs some time to draw the report. As the dimension table contains less amount of data, it can retrieve the data faster and report will come instantly. Only take metrics from the fact tables. All the remaining key columns take from the dimension table. It's all about the entire data modeling.